We're there.
So Denise, I show 15 participants so far, 17.
19.
Yep, it's going up.
Yep.
So we got to wait till we get around 40, right?
Yep.
At least. Hang in there, everybody. Up to 29.
Yep. Let's let the magic number be 35.
Sounds good.
Okay.
So for those who are just joining, we're just waiting for a critical mass of 35 participants, and then Al will take us out with a good introduction here. Thank you all for joining.
Abby, I'm going to go out and come back in for a second.
10-4.
Problem with slides here. I'll be right back.
Oh, we're going backwards.
So Al, in the name of time, if we don't hit your magic number by 103 or 104, why don't we go for it? Does that sound good?
Yeah, that's fine. I've got 103 right about now. We're back up to 31. 32. Come on. 33. 2 more.
I like to imagine that we're actually in a room and Al's here watching people come in the door and counting at them as they come in. No pressure, guys.
1 more. How exciting. All right, we're at 35, so I'm going to get started. Welcome everyone to the SWANA Northern New England chapter's fall technical session, which is entitled Glass Recycling Challenges and Opportunities. My name's Al Sabino. I'm with Casella. Myself, along with Abby Webb from Casella and Bob Spencer from the Windsor Solid Waste District, are your Vermont contacts. This is as a brief description, the Northern New England chapter of SWANA is made up of 3 states, Maine, New Hampshire, and Vermont. Each one of those has a technical session 1 time a year. Vermont's is usually in the fall. We're not quite at peak foliage as I look out my window, but it is, we are getting a little bit of color. So welcome to everybody. We have some really interesting presentations lined up, and I want to start us off with the SWANA Safety Pledge. One of our underlying efforts, not only in the Northern New England chapter, but in in SWANA is this safety pledge, which Abby's kind enough to have put the agenda up. So I'm going to read it. Normally, I'd have everyone stand and cross their fingers on their right hand and hold their left hand in the air, but I'm just going to read it. So, I pledge to help everyone get home safe every day. I will consider worker, customer, and public safety in every decision that I make. My ultimate mission is to serve the community safely for myself, my coworkers, and those who depend on me. If I cannot do it safely, then I will not do it at all. I think that safety pledge really hits home, especially now. It's been a kind of more of an average year for the industry on fatalities. Obviously, we still have the impact of COVID and the variant now starting another kind of continuation of the pandemic. Just as an added note, encourage everyone to get vaccinated who hasn't, other than those that have some compelling reason not to. So with that, I'm going to hand it over to Abby, who's going to take us through and introduce each of the presenters and sessions, and enjoy the technical session. And there's going to be plenty of time for questions. So afterwards, so please hold those or use the chat. We're going to have someone monitoring the chat to try and bring questions up as they're put in. So welcome.
Wonderful. All right. Thank you, Al, for bringing us in. I'm excited to be here talking with you all today, albeit in the virtual space. We put together a nice lineup here. I'm excited to hear from all of our speakers. So I'm going to dive right in. We picked this topic because, glass continues to be one of the trickier materials in the municipal recycling programs. At the moment, these are rough numbers, so these vary a little bit, but let's say it's about 15% of the tonnage on our recycling trucks, here at Casella, and it's about 1.5% of the tonnage on our trash trucks. So there's definitely recycling in the waste stream. It's heavy material, and it's important for us to pay attention to. When I was a student, I think we were told that glass was one of those things that could be infinitely recyclable. That was the phrase they used. What I've since learned in my time in the industry is that while that might be technically true, the economics don't generally support it, especially here in our region. So at most MRFs around the region, glass is managed at a net cost, meaning that it's sort of a drag. It reduces the overall cost effectiveness of recycling. And it doesn't always make its way to best case high quality end use. So I think it's something that we continue to want to pay attention to and to work on. And we've got a great group of speakers to help us do that here today. Today's speakers are going to talk to us. They'll give us a policy, economic, and more of a technical perspective on glass recycling. That'll be our first panel. And then our second panel is going to talk to us about the processing perspective. They're the ones who are actually processing, MRF call it, to make 3 different products. We'll have one representative talking about new bottles, another will speak about using it to make a concrete additive, and another is producing a lightweight aggregate. So 3 different potential end lives or future lives for the glass that we're talking about here today. I'm going to do my little disclaimer. I am by no means a professional webinar operator. I'm going to do my best to be smooth between sharing different things, but bear with me if it's a little clunky. The first thing here is that I have a few videos to show. This is, kind of think of the facility tours that we would like to be giving you if we were in person. They're not super, highly produced or polished, but it's just kind of a peek behind the scenes to give everybody a visual of the types of facilities that we're talking about, and to give you kind of a visual reference. So the first step, I'll try to get myself prepared here. I've got to click over here, and then I'm going to pick my video. So this is going to be Casella's MRF. It's in Auburn, Massachusetts. This will be a virtual tour, just mostly focused on the glass component of that single stream operation. You're going to hear Paul, the manager, talk about sending his facility's glass for use as aggregate. I should mention that, at other Casella MRFs, we have glass going to bottles, we have glass going to fiberglass. It's all very location dependent. But this, what you see here within the MRF is pretty consistent. So with that, I'm going to go ahead and try to make this video work for us.
We take in recycling material from almost all.
Okay, I'm going to restart, guys.
Massachusetts, quite a bit from Western Mass. Recycling material from almost all the communities in Central Massachusetts, Western Massachusetts, quite a bit from Western Mass, and even up into Southern New Hampshire. The glass that we look to recycle is bottle and jar glass, so really household glass. But it's not drinking glass, it's not windows or mirrors, and definitely not heat-treated glass like porcelain or Pyrex. So those bottles and jars get picked up in collection vehicles, curbside trucks. Those trucks come to a facility like this where that glass is all mixed in with the rest of the zero sort. So we take in truckloads of material on the tip floor. We actually inspect those loads for quality to make sure that it is what it's supposed to be. As the material comes up into the plant, it goes by pre-sort, where we have 4 people that do kind of a sorting of the contaminants, things that really shouldn't be in there. And then after that, it goes into the first screen. There's a lot of what we call screens, which are automated pieces of equipment that help to separate out the 2-dimensional material from the 3-dimensional material. That first screen is really designed to separate out material by size, and that's where all the glass is broken, falls to the bottom of the screen. When the glass comes out of the bottom of the system onto that conveyor belt, it still has a lot of paper, plastic, and metal mixed in with it. So the first thing it does is it passes underneath a magnet. That magnet is going to separate out all of the ferrous metal, the magnetic products, so caps, lids, things like that. And then that product goes on to a zigzag chute with a cyclone, and that's basically a large vacuum cleaner that separates out a lot of the paper and plastic away from the glass, tries to further clean that material out. And then the next stage, the product goes to a trommel screen. Trommel screen's a large spinning drum with 2 different size screens on it, and it's separating out the glass by size and also doing one last cleanup, one final cleanup, where it's trying to pull out any more paper and plastic that might be mixed in with it. Right now, all of the glass that comes out of our facility goes for aggregate. The small 3/8- glass goes and acts as a sand substitute to one aggregate recycler. And then the larger glass is going to get crushed, cleaned up a little bit more, try to get more of the paper and plastic out of it, and then that's going as a road base. So as like a gravel substitute. There's not a big demand for glass to be made back into new glass. We still produce a fair amount of glass, so we have to find other markets for it.
New markets are being developed currently and coming online, different types of end markets, whether it's glass going into asphalts or concretes, or the building industry as clear drainage and a number of other types of things.
We have to create markets sometimes, and sometimes that involves some research on new markets. There's some talk about using glass as a cement alternative in concrete. And I know that Casella is looking hard at things like that.
We provide a great product and meet those specs over and over and over again. The glass is still being consumed, it's still being used in packaging in our everyday life.
It all goes back to what we've talked about and learned for years, right? Reduce, reuse, recycle, and it's not just a buzzword or a song, it really does work. We save a tremendous amount of our natural resources and energy by recycling.
All right. So that was our first video, and now I'm going to show you another one here. This is going to be from Urban Mining. They make a concrete additive product called Positive. Pat Grasso is one of our panelists here today, so he'll be talking about it more in depth. I would just say, Pat, I can't see my video right now, but if you're out there and you're interested to sort of dub over this, I know there's no audio or no narrative, the videos, you're welcome to come off mute and describe what we're seeing, or you can just let us enjoy the music. But I'll lower the volume a little bit in case you want to do that.
Thank you.
And we're off.
That's the typical feedstock we have coming in now to our plant. This glass just going its way through the cleaning process. The next photo just going to get the milling process. We agree is the product itself positive. This plant opened up in January of this year. It's ramping up in production now in Beacon Falls, Connecticut. We're updating this video a bit more, but it's hopefully something to give you a flavor of what we put in place. Those are our loadout silos. The finished product is stored, moved out in bulk tanker truck to the users around the greater New York area.
Great. So thanks, Pat. I think I'm gonna stop sharing that. So I've got a couple other video clips from strategic materials, but since Laura's not here to sort of narrate over them for us, I'm gonna say we'll hold off on those and get those when she presents later on this afternoon. So we're a little bit ahead of schedule, which is wonderful. I can advance to the next slide. I think, we can go ahead and dive into our first panel. So again, as Al said, if you have any questions, you can submit those by typing in the chat window. We'll address your questions. We've got some time set aside at the end of each panel, and then a little more time at the very end of the session. So our first panel, as I mentioned, is going to provide perspectives on glass recycling through the lens of policy, economics, and technical engineering. I'll briefly introduce the three speakers, but you can look to our program that Denise sent around for their full bios. So first we'll be hearing from Josh Kelly with Vermont DEC, where he serves as Materials Management Section Chief. Next up, we'll hear from Ted Ziegler with the consulting firm DSM Environmental. And then last is Eric Steinhauser, a Principal and Senior VP with the engineering firm Sanborn Head. All three have extensive credentials and experience in our industry, so I'm really looking forward to their remarks. I think, why don't we just go ahead, Josh, I will let you take it away.
Great. Thanks, Abby. And thanks, SWANA members. And actually, let me just extend that thanks to all solid waste employees and to all of you as solid waste managers out there. I don't collect materials and I don't process them, so I always want to just stop and pause and give credit to those who do and the employees that work for them and in their organizations, both governmental and non-governmental, the private sector as well. So thank you for all you've done for the people of Vermont and around the region as we've undergone one of the craziest times that we've lived through. I am at work and in the recycling witness protection program, so that's why I look a little, I don't know, the light seems to be shaded here, so please bear with me with my shadow. I'm just going to give you a little bit of the perspective on glass from Vermont. I can't really speak to the other states, but I will sort of give you some of the overview of where we've been in Vermont. let me just say, I think it kind of came out in some of the videos, but glass use as consumers continues. And maybe that's just a foregone conclusion, but there's a lot of discussion about preference for materials or sustainability of materials. And yet I just queried a milk producer. Vermont is a big dairy state. This milk producer uses glass, reusable glass containers. And they sent me to a Facebook post they had made about whether to switch to plastic. And they had so many comments about gratitude for them staying with glass. It was just, obviously this is one company that decided to go this route, but people have a demand for beverages in glass. But it just kind of depends, and there's trade-offs. So we'll talk about some of that. So in Vermont, in 2012, the state passed its universal recycling law, which was really aimed at getting recyclables out of the waste stream and organic materials like leaf and yard debris, clean wood, and food waste. And it put in place a mandate, a ban, a mandate on recycling certain materials and a landfill ban on those materials. So it is no longer allowed, as of July 1, 2015, it's no longer allowed to throw away your recyclables in the trash, and they must be recycled. And that includes glass bottles and jars from food and beverages. So that law began in 2012, its implementation, and the recycling part took effect in 2015. The law uniquely also required trash collectors of facilities and haulers to offer recycling collection for those mandated recyclables. So it was trying to make it as easy to recycle as it was to throw something away. So we have recycling across the state, but it's not all the same. It didn't dictate how you collected that recycling. We have probably definitely the majority of Vermont's recyclables are managed single stream, but we do have source separated collection centers for recyclables. And we still have some dual stream, but it's definitely the exception rather than the norm. There was a material recovery facility doing dual stream when the law first passed down in the Wyndham area and subsequently closed during the time when the rollout was happening. But essentially, Vermont's goal has been to make recycling easy and to do that because it saves landfill space, it conserves energy, it conserves resources, it reduces greenhouse gas emissions, as we know from using these materials. And so that was the drive. That was the goal behind that law in 2012. We as a state, like many other states, have a recycling rate goal, which is to recycle or compost or reuse 50% of our materials. And we've just been not meeting it. We've historically not been meeting it. Now, people can debate how effective, if those are the right metrics to use, but we have had that metric for a long, long time. We continue to have that in our state solid waste plan. And here's the data. I'll share some of the data on glass. We feel like we're in a good spot with glass. But before I talk about where we're at, I also want to acknowledge one of the things that hit the region and impacted Vermont as well, which was the closure of the RDAW bottling plant, which sort of sent ripple effects around the region for glass markets. And Vermont was definitely one of those. So that really dropped the value. Well, not the value so much, but value is relative, as many people will talk about with glass, but dropped the markets for that material. And as far as I know from that closure, and there's people with much better knowledge here, part of that shift is consumer shifting from beer bottles to aluminum, I believe. I don't know that. I've read some articles about the RDOT closure, but again, people here know more about that than I do. And that was happening, just a little bit after we implemented the requirement on mandatory recycling, landfill ban on recyclables. So it was definitely hard to have that happen at that time. I will also mention that how you collect glass continues to be talked about because it obviously wears on equipment. It wears on trucks, it wears on MRF floors, it wears on anything that turns or moves. Glass is highly abrasive. And there was at least haulers in the Northeast Kingdom who complained and talked to us about having markets for recyclables in Canada, but not with glass in the mix. They could take mixed recycling as long as glass was not in it. That was the only story I heard of that in our Northeast zone, but I've heard of that in other places across the country when you saw glass starting to be dumped as a result of sort of the China sword market stuff. This is just anecdotal information about what we've seen and some of the past history we've had with glass. But let me get to where we're at currently. Our best data from our 2018 waste composition study shows that we're recovering about 77% of glass bottles and jars currently. That's not counting our bottle bill. That's a separate stream, and the bottle bill estimates are around a 75% recovery rate. I think both of those numbers are good. And I think, recycling is something that Vermonters have embraced for decades. They continue to demand it. They continue to want to do it. They also have to realize that it's not free, and they have to realize that the bottle to bottle glass, reality is, again, an exception rather than a norm. It's very rare for glass to come back into your bottle, your food or beverage bottle. And let me just, on that, we have two streams of recycling with the bottle bill and with regular recycling, what we've referred to with some others as blue bin recycling. And we feel both are good, but we admit that having two systems is, obviously there's more work involved in having two systems. It's not as efficient. But the bottle bill can have, especially in terms of glass, potential higher and better uses for that glass. There is that potential there. And there is a bill proposing expansion of the bottle bill that is from the last legislative session, probably will be discussed this legislative session. And I think when we look at the data, expanding the bottle bill is more likely because of the high recovery rates that I was mentioning. Expansion is likely just to move the material from one stream to the other. Like, for example, if the bottle bill is expanded to include wine bottles, which make up a decent amount of the glass in the blue bin recycling system, that really sort of takes it out of the blue bin recycling system and puts it into the bottle bill system. That glass could be available for potentially higher and better uses, but MRF operators know they're expecting to continue to manage glass in some way, shape, or form. The pickle jars, the pasta sauce jars, etc. So we'll see. This is just what I'm aware of happening now. And again, I think both our bottle bill system is good and our blue bin recycling system are good. Both are really helping Vermonters to get their materials to better markets and end markets of some kind. Next, talking about markets and what I know briefly in the Northeast, we have Glavel here. Obviously I've heard that Glavel's facility is moving forward. And Rob can talk more about that. I know there's some powdered glass initially that will be imported, but maybe there might be a potential to use MRF glass in the future. I just think, as we all know, glass is going to continually be managed by solid waste managers. The question is, what are the emerging markets? I know that Chittenden Solid Waste District, UVM, and Casella are looking at sand borrow with our VTrans. And if as a processed glass aggregate to be used as sand borrow, if that can happen, certainly could increase the value of MRF glass as a possible commodity. I don't know how fast that will happen or if it will happen, but I know those discussions are ongoing. And then lastly, the topic of refillables. It seems like we're always having one of those presentations at the Northeast Recycling Council conferences or other conferences that I go to. And it's exciting to see people trying that out as companies try and figure out which path they want to go for the sustainability of their packaging. I'll say that I contacted a milk vendor in Vermont, a company who provides glass reusable returnable bottles. I think they have $1 deposit on, this is a voluntary program, on their largest, it's like a 1.5 liter milk container that goes back to the plant, gets washed and is sent back out. And they had some pressure to switch to plastic after another dairy closed, another organic milk dairy closed that used to provide most of the plastic beverage containers for a lot of retailers. But they decided to stay with glass. They really feel strongly about it, and they have an extreme customer base that likes that, that their beverages are in glass, and that's why they flocked to them. So there's a lot of personal choice out there when it comes to glass. I will mention that I think refillables may be challenged a little in Vermont based on what little I've seen of the craft brew industry. So a lot of the refillables I see in other states where companies are getting into that space is because it's around beer, beer refillables in some way, shape, or form. A lot of Vermont's craft beer has switched to aluminum cans. And so I don't know if they will consider switching back. And I know, again, that RDOC closure, the article cited beer, the switch from beer in bottles to beer in cans as part of the reasoning there. So Vermont certainly has goals to keep recovering glass and trying to find ever higher and better uses for it. I believe that minimum post-consumer recycled content in glass bottles and jars could benefit all potentially, but I don't know if that will happen. So that's me. I'm happy to take questions or wait till after, as Abby, as you direct.
Wonderful. Well, thanks, Josh. I think we'll stick with our plan to save the questions for the end of the panel. So you guys don't have to stick around till 3:30, but more like around 1:45 or so. We'll get back over to Josh with any questions. So next up we have Ted Ziegler. He's gonna round out the perspective a little bit more.
Thanks, Abby. Hopefully I will get this right. Oops. Okay, can everyone hear me?
Yep, you're good to go, Ted.
Great.
Thank you.
The problem child of single stream MRFs, I think that most people, obviously people who know me, know that DSM does a lot of sorting of garbage, but also recycling, and have sorted in almost all of the single stream MRFs in New England. And I think it's fair to say that in every case, people raise the issue associated with glass in the MRF and the impacts that it has on the MRF. Abby kind of related to this at the beginning. Based on the data that we have from different states, glass represents somewhere between 15 and 20% by weight of inputs to the MRF. And is typically the only commodity with a negative value, depending in some cases on the MRF in the market, but that's pretty much the case. It is typically, as Paul said in the video, removed at the beginning of the process to reduce conveyor wear and cross-contamination of other materials. And if it is going to be processed for bottle glass or fiberglass, it needs to be greater than 3/8 to 5/8 inches in size to further process that material. And at that size, it typically, for those who have seen it coming out of a MRF, contains a significant amount of less than 2-inch material, such as bottle caps, chicken bones, surprisingly, shredded paper. Those are all fairly obvious whenever you take a look at the glass coming off of those initial screens. This is an audit, Camden County, New Jersey MRF audit that we conducted fairly recently, just to give you an idea of what the impact of glass is on the total revenue. The Republic Industry operates the MRF. It's owned by Camden County. And so we were doing an audit of the truckloads coming into the MRF, looking at residues. But as you can see, glass has a significant negative impact on the overall revenue value of the material coming out of the MRF. In most cases, to process the material, the MRF needs to first process it to make it marketable to a glass processing facility, and then it needs to be further processed at what I used to call a beneficiation facility. I don't know whether people just call it glass processing anymore, to produce either bottle grade cullet or an input to the fiberglass manufacturers. Strategic is obviously probably the largest secondary glass processor in the US. Some others that I'm familiar with or have done some work with, including include Rumpke in Ohio and Monument Glass in Colorado. And glass processing typically includes sorting out contaminants, color sorting, bottle glass, 3/8 and greater, and then pulverizing the 3/8 minus material for fiberglass inputs. The economic problems with glass are that the energy savings associated with substituting cullet for virgin materials are not, while there are some, they're not anywhere near as great as the energy savings associated with other materials. Roughly a 13% energy savings associated with cullet going into a furnace when compared to 90% for aluminum, 75% for recycled PET when you add in the virgin material extraction on top of it. And it requires, bottle glass especially requires a very specific input of clean cullet. I am by no means a glass engineer or chemical engineer, but we did do a study for the state of Ohio and learned a lot from a couple of the glass bottle manufacturers there about limitations for input of cullet. Obviously, for clear bottles, it requires clear cullet, but amber also has chemical reaction for production of colored bottles. And so there are real limits on the amount of amber that you can introduce. And ceramics are not tolerated in any case because for bottle glass, they introduce a contaminant that creates a bottle that can't be sold. The limitations for fiberglass inputs are less, but it must be pulverized to a size so that any ceramics or other non-meltable materials will pass through the fine nozzles of the spinnerets. Those spinnerets are located just below the furnace, which is typically on the roof of the facility. So you have hot molten glass above you coming down into a series of spinners. Those spinners jam and they have real problems with those nozzles jamming up. And so it becomes a real issue that the size be, anything that's not meltable be pulverized to a size that fits through there. So basically the crux of the problem is that glass manufacturers cannot pay very much of a premium for cullet, meaning that the glass beneficiation plants cannot pay much for the material coming out of the MRFs, and transport costs of the MRFs for glass to processing plants are high, given how heavy glass is. That is why bottle bill glass is so valuable for glass beneficiation plants, because it is typically much less contaminated and often color sorted. But the problem is that not all glass is subject to the bottle bills in deposit states. This gives you an idea. This is a study we did in Massachusetts in 2016, looking at the total amount of glass sold in the state. And as you can see, material bottle glass subject to the deposit in Massachusetts. And Massachusetts did not have a expanded bottle bill, so it didn't include wine. The amount sold is less for deposit material than other material. And the amount that is collected for recycling of roughly just under or around 99,000 tons for other recycling. So that's material going to the MRFs versus 87,000 roughly for material going through the bottle bill. But then you look at the net recovery and you can see that the high quality of the bottle bill material means that the net recovery is significantly higher for bottle bill material than it is for the MRF material because of the loss rates associated with contamination at the MRF. An expanded bottle bill will help, but still there would be a lot of available to the MRF. This is the Vermont Waste Composition study that Josh referred to. And this table does two things. One, it shows you it illustrates the economic problem with an expanded bottle bill. For those of you who know me, you know that I am not a great fan of expanded bottle bills. And the reason for that is both because of the high costs associated with bottle bill recycling, but also because it removes, an expanded bottle bill removes, while it removes a lot of glass, it also removes a significant amount of valuable PET and aluminum from the MRF. As you can see, the expanded bottle bill would remove another 777 tons at the time we did this of PET bottles that are currently going through the Casella MRFs and the Chittenden County MRFs in the state. and would remove another 329 tons of aluminum and, or no, 120, what is it? 123 tons of aluminum. And both of those materials right now are extremely valuable to the MRF. They have some of the highest value of anything going through the MRF. So while you would get more glass, you would also remove significant amounts of material that the MRFs really can use and that generate a lot of revenue for the MRFs. So as I said before, the problem with bottle bills is that they are a costly system overlaid on a comprehensive municipal system. There are significant costs to the consumers, and there are significant revenue losses to the municipal MRFs. So when we talk about expanding bottle bills to include all those materials, there are significant costs associated with doing that. And the impacts on consumers and on the environment associated with bottle bills are pretty significant. This is a study we did for the state of Vermont. It's a while ago, but it's probably still pretty valuable, in that roughly 23% of the deposits are not returned through the deposit system. And so the escheats are captured by the state or by the bottle manufacturers. And so that becomes another 3 or 4 cent cost on every container that consumer buys. In addition, the consumer is paying a 3.5 to 4 cent handling fee over and above the 5 cent deposit fee, and they never recover that because that goes directly to the bottler who initiated the deposits. But probably most importantly, because it's a separate system, consumers have to bring bottles back to someone else. And when we did the work in 2006, consumers, based on our surveys of deposit returns throughout the state of Vermont, we estimate that consumers drove just under 1 million miles a year to, or made just under 1 million trips and drove 7.6 million miles, costing them about $3.67 million based on the IRS mileage rate. And that was equivalent to 3,000 metric tons of carbon dioxide equivalent emissions per year. So requiring consumers to return these beverage containers under a separate system essentially has relatively significant costs and environmental impacts associated with it. We have taken a look at what we estimate are the total system costs associated with an expanded bottle bill. And obviously I'm focusing on an expanded bottle bill because that is where the majority of the glass, the clean glass, would come from if you were to try to move glass to make glass more valuable. And we had concluded that the expanded bottle bill would increase costs by roughly $4 million a year in Vermont, while capturing about 4,000 tons of material. And that includes the reduction in recycling revenues of roughly 50% because of the loss of aluminum and PET. We did a study, the same study in Massachusetts, or a similar study in Massachusetts for the Mass Beverage Association, looking at what was the best way to deal with glass only, because glass, as I said, is the problem child at MRFs. And essentially what we were looking at is what does it cost to collect and redeem glass through a deposit system? And then what do you get in terms of the amount of material and the total cost? And as you can see, the deposit system is costing roughly $300, over $300 per ton, compared to a MRF system of about $200 per ton. But by the time you get done with the losses associated with the MRF glass, while the costs narrow, the MRF system, assuming that you can clean the MRF glass to a point where you can reuse it for bottle grade and fiberglass, while the costs narrow, the MRF system is still slightly less costly, primarily because of the high costs to the consumer associated with the separated system. So when we looked at what the alternatives were, we came to the conclusion that the expanded deposit with no curbside glass would be cheaper than the existing system. No deposits would be less expensive. And the one that had the lowest cost would be no deposits with a significant enhancement in the collection and processing system in Massachusetts, but you would get less material. As you can see on the next to lowest row, the recovery rate would be the highest for an expanded deposit with no curbside glass, with the next one being no deposits, but an enhanced collection and processing system. So in essence, if we wanted to invest the money in the system in New England to make sure that every MRF was sending relatively clean glass to a processing facility in New England, and that processing facility was capable of producing both bottle bill glass and fiberglass inputs, we could have a system that would, without a bottle bill, that would be less costly than an expanded bottle bill, but would also recover less material than an expanded bottle bill. So basically the conclusions, the current system with a deposit on some glass is the most costly alternative, whether it's in Massachusetts or Vermont. And as Abby has said earlier, we're going to get glass at the MRFs no matter what. Even with an expanded bottle bill, MRFs are still going to have to handle glass. But if we were to eliminate glass from the curbside programs and provide drop-offs for glass recycling together with an expanded bottle bill, we would have the highest recovery rate, and we would have much cleaner material for input into a glass bottle and fiberglass plants. And the system that we preferred, based on the Massachusetts analysis, is really almost identical to what's happening in Ohio, where Rumpke runs the three largest single stream MRFs in the state, and sends all of their glass to a single processing facility in Dayton, Ohio, where they do clean it up to the point where they can access, excuse me, both bottle production facilities and fiberglass plants. But they're lucky in that there are bottle and fiberglass plants near or in Ohio that they can market to. We don't have that in New England. And that really concludes my presentation. I'm happy to answer questions if people have it, or just wait until later on.
Thank you, Ted. Lots of good stuff to digest there. I catch a little bit more each time I see your slides there, so thank you. Why don't we jump next to Eric Steinhauser, and then we'll put the three of you on the hot seat together to tackle the questions after that.
Abby, I'm going to try to share my screen again. Oh. And go to, is that working this time?
It is.
All right, so we're in business. Well, good afternoon, all. I hope you're enjoying this virtual conference so far. As Abby mentioned, my name is Eric Steinhauser, and I'm with Sanborn Head and Associates, based here in beautiful Concord, New Hampshire. And it's my pleasure to talk to you about recycled glass and potential end uses. And I think you'll find that my presentation is going to be a little bit of a bridge between what Josh and Ted spoke about and what we're going to hear in panel 2. So here we go. So the issue at hand is that hundreds of tons of waste glass is produced every day. And it's, as we talked about, it's glass is pretty much 100% recyclable if we can. So we need to understand what waste glass really is and in different ways it can be used. So for a little perspective, this is from EPA study that ended in 2000, the data through 2018. About over 12 million tons of waste glass is generated in 2018. About 3 million or so of tons of glass was recycled, and the remaining almost 9,000 was either combusted in energy recovery or was landfilled. And if you consider that in 2018, over 292 million tons of municipal solid waste was generated, glass makes up about 4% of that waste stream. It also makes up just over 4% of the waste that's recycled. Interestingly, this graph, which goes over about, if you can take it out to 2021, is about 61 years of data, and really about 30 years ago did we start seeing any significant glass recycling taken care of. And what's nice is that while the amount of glass landfilled has gone down, the amount of glass that's actually managed other than in a landfill has been really flat for the last 30 or so years. So what are we going to talk about for the next 10 minutes or so? Well, we're going to look at the wonderful world of waste glass and recycling and some of the applications that are out there. And again, I'm just going to tee up some of these. We'll hear more detail on a few of them in the next panel. So I think it'd be important to understand what types of glass there are. And there are about 6 different types of glass that are made. And just to kind of go through these quickly, the most common type is the soda lime glass. That makes up about 90% of the glass that's manufactured. And the soda lime glass is what you pretty much see every day in your usual use. And it's a glass that is resistant to high temperatures, but not to sudden changes in temperatures. And it's not as resistant to corrosives as we might like to see. Lead glass, as you might imagine, contains lead, about 20% lead oxide. It's softer glass. It's used for nice crystal because it has a nice brilliant refraction when you cut into it. It's more expensive than the soda lime glass. And it's also favored for electrical applications because of its excellent insulating properties. It's not good for high temperatures and for sudden changes in temperature as well. The borosilicate glass contains about 5% boric acid, is really good for high temperatures and for chemical corrosion. It's used in pipelines, light bulbs, photochromatic glass, sealed beam headlights, laboratory ware, and bakeware. So you probably have some of this in your house. The aluminosilicate glass is a cousin of the borosilicate glass if it has an aluminum oxide in it. It has a greater chemical capability, can withstand high operating temperatures, but it's more difficult to fabricate. And a lot of times it's used for electrical resistance in electrical circuitry. 96% silica glass is another cousin of borosilicate glass, except here most of the non-silicate elements are removed. It's really resistant to heat up to 900 degrees Celsius. And it's used for like furnace sight glasses in the outer windows of like the space shuttle. So it can resist the high heats of reentry to the Earth's atmosphere. And last and probably least is the fused silica glass. It's a pure silicon dioxide material. It's very difficult to fabricate. It's very expensive to make. It can take temperatures up to 1200 degrees Celsius for short periods, and it's used for very specific astronomical type of applications. So a lot to glass, other than what we just putting in our recycling bin. So let's talk a little bit about where we're going to take our glass. So here's the typical glass recycling cycle, and this is based on a endless bottle to bottle model. And for our considerations, we're going to look at taking processed or beneficiated glass from steps 3 and 4 here and doing something else with it instead of making it into bottles or perhaps the fiberglass that was mentioned. So the waste glass, which is known as cullet, also called crushed glass or recycled glass, can be made into a bunch of different sizes, as we heard, and types. And understanding that there's many different colors of glass, and the colors of glass have a little bit different chemical composition. For example, blue glass has chromium, and that can have implications in its reuse, the chemical composition of the particular glass. So going back to our cycle of recycling glass, we're going to be interested in taking that cullet and doing something other than making bottles. And that's what we'll kind of explore here in the next few slides. So the applications we're going to look at are these here, the processed glass aggregate or PGA, how we can use it in landfills for other structural components like in concrete or surfaces. And then this concept of foam glass aggregate, which we'll hear also more about later and then just real briefly on some other uses that are out there. So processed glass aggregate, or PGA, is a very good use for waste glass. It requires no color separation. It is processed by taking the glass and grinding it down so there's no sharp edges. And we can use or make PGA from regular glass that's in our recycle bins, ceramic bottles, glass jars, ceramic tableware and cookware, vases, plate glass, mirror glass, incandescent light bulbs, all sorts of glass like that. PGA should not be made of some larger things like large ceramic items like bathtubs and toilets and sinks and the like. We shouldn't be making PGA from laboratory or medical waste glass, TV tubes or computer monitors, or fluorescent glass or fluorescent light bulbs because of the other chemicals in there. It's not very good for automotive glass, tempered glass, in glass that it was containers for hazardous materials. Depending on the processing that is done, the PGA can either replace sand or aggregate. We've heard Josh talk about that. The material compacts well, it can shed water, and because it doesn't have the silt and clay-like particles, its frost susceptibility is very low, which gives it some other benefits. This graphic here of a PGA survey was launched in 2020 by the Northeast Resource Recovery Association, which is actually not far from me here in Concord. There were 18 participants in the study from Connecticut, Massachusetts, New Hampshire, New Jersey, and Vermont. And they indicated that these groups have been using PGA since 1978 with pretty good results. I wanted to point out that the NRRA has a PGA program that has 3 consolidation sites in New Hampshire, one at the town of Littleton transfer station, one at the town of New London transfer station at the waste management facility in Rochester. Once each of those sites gets about 1,000 tons of glass, NRRA comes in with the processing, and it'll make the glass into the cullet that the NRRA members can use for projects as listed on the slide. And if you're interested in the NRRA association, their programs, you can go to visit their website. This graphic table is also from the NRRA website and identifies the allowed uses of PGA in the various New England states. And what you'll see here is that Massachusetts, New Hampshire, Vermont has pretty good acceptability for PGA in a bunch of different uses. And we'll talk about the landfill ones in a couple of slides. And I also wanted to point out that AASHTO has a standard specification for using glass cullet as a base course material. So moving over to landfills, cullet can and has been used to replace daily cover soils. And when you do that, you get this nice sparkly cover system over your waste. And we've also used it in the landfill gas collection trenches to replace the aggregate. When doing that, you got to make sure that the size of the particle is the size of the cullet is the correct one, because you don't want to be causing worker safety issues, and you want to make sure you have for cover soils we're shedding water, and for the trenches that we're actually able to have a large enough particle so we can be moving gas through the system. So please make sure you're working with your engineers to pick the right size particles for that cullet in these applications. I know we'll hear a little bit more about this, but again, just to tee it up, considering that concrete is 70% aggregate, it's possible to use the cullet to replace the aggregate. And in doing so, there might be an impact to the structural capabilities of the concrete. And I understand there's some conflicting research on that, so we might hear more about that from Pat later. And also the color of the glass, again, the chemical composition of the glass can have an effect on the curing process or in cracking of material. But we can be using either glass cullet as an aggregate size or a powder in the paving blocks. And this material, as Pat will probably talk about, is well studied. Lots of publications that address the benefits and concerns of using cullet in concrete. Again, please work with the professionals that understand structural concrete and how it can be used. Another item, which I think is really cool, is using either glass cullet or porcelain aggregates as surfaces. So whether in countertops for like your kitchen or bathroom or tables, 85% of that can be recycled glass or porcelain. And on the right, we're showing a picture of glass mulch that you can have in your garden. Reportedly, this material retains moisture well, reduces evaporation, and doesn't absorb the water like a wood mulch would and would rot away. It's good for garden pathways where we're going to be concerned about erosion or drainage. And it can also be used within aquariums or in fish ponds and other applications where we can apply glass in a safe and appropriate manner. The other interesting and very well used is foam glass aggregate. I believe it started in Europe and is getting more popular in the United States. There's a couple of groups that make this. Another great idea is that it's not a color-based item, as I understand it. The aggregates are really light compared to what is quarried, and which is a benefit for many geotechnical issues if we're using aggregates. It's also great for trucking the material, and you can get a lot more material in a truckload than otherwise would be used. And it can be used for all sorts of civil projects as listed here. Also, the foam glass provides a great insulator as well as a drainage material. Its friction angle is very high. I understand even when it's compacted, there might be a little breakdown of material, but it still has a very, very strong compacted state. Again, because there's no fines of clays and silt, it's not very frost susceptible, and it's relatively easy to compact. And again, I think we'll hear more about this material in a little bit. There's a host of other uses for crushed glass or glass cullet in blast media, using in highways, for sandpaper, and other applications. And time does not allow us to go through all that today. But I hope that your interest is piqued in what other uses there are, and you can do some of your own research for these materials. So I hope you found this interesting. It was pretty quick. But again, we'll hear more about some specific applications in the next panel.
Wonderful. All right. Well, thank you, Eric, and thank you to everybody on the panel. Lots of good information there to set the stage for the rest of the discussion. I have seen some questions come in the chat. I would encourage people to feel free to layer on there because we've got some time set aside for exactly this. Why don't we just start things off? There was a question about the percentage of glass in the blue bin or curbside systems. I think Ted touched on this, but I guess I would throw that back out there for folks to answer that, maybe elaborate on sources and anything else you want to share there.
Abby, if you would, the slide on Massachusetts showed what percent of material was going through bottle bills in Massachusetts and what percent was going through the MRFs in Massachusetts. And Josh touched on the fact that the recovery rate for glass going into the MRFs in Vermont was roughly 77%. But obviously what's coming out of the MRF and actually being used for glass, either for bottles or fiberglass, is lower because of the contamination rate. So I think the rate we estimated for Massachusetts was roughly a 55% recovery rate for the state of Massachusetts coming out of the MRFs, as opposed to probably a similar rate going into the MRFs, although we don't have waste composition data for Massachusetts.
Yeah,
Thanks,
Ted, thank you for that. I was checking with my supervisor, Kathy, who gave me some of the figures. I think here's what I had wrong. I was separating out the recovery rate for blue bin versus bottle bill, and actually 77% recovery rate for glass food and beverage containers is both of those systems. So I had that wrong. I apologize to people listening. As Ted knows from the DSM study, waste composition study of 2018, their overall recyclables recovery rate estimate was 72%. That's fibers and containers, and it's not specific to glass. But that was their overall figure from that study of looking at what's in the waste stream that is what we call mandated recyclable, and food and beverage glass containers are included in that. The estimate is 72% recovery rate of that. So just to be clear, 77% is Vermont's both streams, blue bin recycling and bottle bill recycling for glass containers. And I think I have some calculations I can dig into later on that.
Can I also just add, one of the issues that we've found, having tried now several times in Vermont to get at what the bottle bill recovery rate for glass is that in order to do that, you have to make a series of assumptions about the size of the containers, and you have to make assumptions about imports from other states coming into Vermont's bottle bill system as opposed to material going the other way. And of all of the materials that we deal with, and I'm Natalie Starr, from DSM is really the kind of numbers guru. She always is just scratching her head trying to figure out what the real number is for glass. It's very, very difficult to come up with an actual recovery rate for bottle bill glass in the state because there are a lot of variables, and we don't have access to all of those variables. No one does.
Right. So yeah, it's a complicated question. I am just looking back at the wording of the question was actually specifically, can you cite the percent of glass in blue bin systems? So if the question is more just what's coming into the MRFs, or what as a percentage of the total stream coming in, I think that at least for Casella is more in the 15 to 16, 17% range generally. But again, a lot more nuance when you start to ask, recovery rate overall and how much, that I think Josh and Ted covered that well. But I wanted to give the simple answer in case that's what you're looking for. So let's see, we've got another one here. We have someone saying that what I'm hearing is that glass can be reused in other products, but it's not being recycled into another glass bottle. Is that correct? And can you clarify? Also, virgin glass used as mined materials. Correct. So I guess let's throw that one to Eric. Do you want to talk a little bit about that one?
I'm not sure I'm the right one to answer this one. Glass can be recycled into other materials. I believe there's bottle to bottle programs, and I think they have to be color sorted because you can't use a green bottle to make a clear bottle, as I understand it. And if you mix the glasses, then you get, a different product out of it. So you can make it into other bottles if that's what the process is and the processor can do. And my understanding, if you're doing virgin glass and you're using all virgin materials, you're probably using quarried materials to make that. I don't know if Ted or Josh have something to add to that.
I could confirm just, Eric, what you said, so a lot of our, deposit glass, material passing through redemption programs, I believe that, a portion of that goes into new bottles. And then some MRF glass also is being sent for further processing and to become bottles. Our Rutland MRF in Vermont is an example of that. So I think that's, if there's one takeaway here, it's that there are many things we can do with glass, and we're doing sort of all of them right now in various ways. And we're just trying to look to see how do we continue to push the material to the highest and best use wherever possible. Ted, you were starting to jump in.
Well, I mean, as Joe said earlier, the loss of the Ardagh plant in Massachusetts was a pretty big blow to bottle glass recycling in New England. The closest glass plant that could accept glass now is a fiberglass plant in Albany area of New York. Otherwise, we're looking at long transport costs, both to get the material that could be processed into bottle from MRFs to a strategic facility primarily, or up into Canada, and then a long transport cost for the clean cullet to a bottle plant. So it's not surprising, given how little a bottle plant can afford to pay for cullet compared to their other inputs, that there isn't a lot of bottle cullet or cullet going into bottle glass in northern New England.
Sure. I'm going to keep my eye on the chat. If anybody has anything else, you can put it there. I had one for you guys. I heard a few mentions of greenhouse gas emissions and climate, but I'm wondering if you could dig into that a little bit more. Is glass recycling a climate issue? Can it help us reduce emissions?
I can start, and then maybe Ed and Eric and Ted, I just combined their names, can follow on. It depends what the downstream use of it is. So if you're using, and this is from what I know from hearing presentations by Owens Corning, the insulation makers, if they include glass cullet in the foundries that make fiberglass, it melts at a lower temperature rate or improves their outcomes in terms of fuel use versus virgin sand. And actually, to the other person's question that was in the chat, essentially glass is sand. So it's highly available. When you say quarried, usually basically what we're doing in New England is we're mining gravel from glacial till. I mean, it's like, so it's available all over. The sand is available. And that's not just a Northeast thing, it's available in many places. So you have to try and compete with the low cost of sand for many of these uses, even bottle to bottle, or other aggregate uses. But generally in the insulation and in the bottle, my understanding is the melting point of recycled glass is better than from virgin sand. So there's a greenhouse gas emissions, but it's heavy trucking it around. And the other thing I just want to mention is that having a diverse array of market options, because as Abby said, there's a chance for the Casella glass to get used in bottle to bottle, but that depends on how it breaks. Because as Eric said, the color really matters. So if a wine bottle breaks and there's a chunk about 2 by 2 inches, that might be sortable by the beneficiating company. Is it strategic or 2M or whomever, to be able to be sent to bottle uses if that market exists. And having all of these options is good. The more options you have, honestly, for a material, sometimes the better, because not any option, it's just, you have more diversity of uses for it. And how the glass breaks really does kind of matter in that, and how it gets collected. And so, yeah, I don't know if that helps, but I'll leave it there. I'll let Eric and Ted jump.
If I jump in, I did show a slide early on, which showed the warm model results for glass versus PET versus aluminum. And Josh is correct. The introduction of cullet reduces the temperature of the melt, but the overall greenhouse gas savings are roughly about 15% for glass when compared to 90% for aluminum and 75% for PET. And that's primarily because the greenhouse gas impacts associated with mining and processing aluminum and PET are very large compared to mining sand for production of glass. There are a couple other materials involved in glass manufacturing that have higher greenhouse gas emissions. But overall, if you look at the warm model, the savings, the greenhouse gas savings associated with glass are relatively minor compared to other materials.
I really don't have much to offer in addition to what these guys are saying. But if you're like at a landfill and you have, as a landfill operator, you have a pile of glass that's the right size and you can use it for daily cover or for your gas collection system, then there definitely is savings because you're not bringing in material, you're not trucking as much. So there's a greenhouse gas savings there, but it's a much more smaller impact than I think what Josh and Ted are talking about.
Great. So a related question, on this theme of, and I think we understand that the real environmental benefit of any recycling program, it is sort of predicated on what upstream activities are you able to prevent from happening. So I think, that we touched on that from a climate perspective, but what about the more general environmental impact of sand and gravel mining? Is there anything you want to add in terms of, habitat or water management or anything like that? You read about sand and gravel mining on a global perspective as actually starting to impinge on some pretty delicate ecosystems. Is that an issue regionally, or is that more in other parts of the world?
We are actually starting to run out of sand. So it is an important issue. And so finding replacements for sand are important. And one way of doing that Eric talked about is to essentially substitute recycled glass for sand if you clean it and get it to the right size. So yes, you're totally right, Abby. I was concentrating on greenhouse gas emissions, but there are clearly other environmental benefits associated with using glass in something other than just burying it in the landfill.
Josh or Eric, anything to add there?
I guess I would go back to that sand borrow. Sand borrow has a value, or borrow sand as it's called, and if glass can meet that spec, then that's a good market for it, and it can be used immediately in the area where it's made, and so that really matters. That, I think when we talk about greenhouse gas emissions, the angle at which you can enter that conversation is so varied. You can enter it from the full upstream zone, from I'm a beverage producer and I'm thinking about how am I going to package my beverage to get it to you all as consumers. And there's a study done on glass versus PET versus aluminum, which one's best. And I can't remember the authors of the study, but they basically came out this way, that the aluminum was the first, PET was a second, glass was, but if glass was reused, it could compete, but only in the reuse, only in the wash bottle, really, not in the glass being melted and put back into your hand as a new bottle. So that you have to kind of think about what life cycle analysis are you doing? What factors are you comparing? Is the life cycle analysis for greenhouse gas emissions? Is it for habitat loss? Is it for water? Is it trying to bring all those things in? And if, as with anything, there's a lot of trade-offs in our lives. If we have two streams for stuff, there's a chance for bottle stuff to go to a higher and better use, but it doesn't mean that, but as Ted shows, there's different material that's going to go in those different ways, and MRFs are still going to have to handle some of this. So there's a lot to pack in.
Again, I think Ted and Josh have a much broader view. When I look at these, it's harder and harder to develop greenfield projects. So if you wanted to establish a new sand borrow source or whatever, it's harder to permit those environmentally and politically and socially. So if we could be reusing materials, I think it makes it better overall on many different levels.
And do you guys just said that we had one follow-up question on sand borrow? Can you just sort of confirm or reiterate what you're talking about there?
Yes, I'm sorry.
Industry term that we throw around.
Essentially, it's a quality. it's a sand pit quality standard for construction uses of sand. And so, if you think about what would be, they call it bank run gravel. When the loader goes into the side of a gravel embankment, pulls out material, it's glacial till. There's rocks and stones and stuff that's as big as a watermelon, and there's stuff that's the size of a baseball. They have to sort that out. So sand borrow or borrow sand is just a general industry term for a finely sifted grains of sand in construction uses. It's a spec that is used in roads that is highly technical. And if glass can be made to that spec and meet that spec, this also goes to the other question. If the labels are removed and the caps are taken out to the extent that it's clean enough to be used, in that use, that construction use, then it has a positive value, at least at the point that after it's been processed.
Great. And I can appreciate that question, Sherry. I think the first time I heard the term, or probably the first several times I heard it, I was like, it's like borrowing. It's like, it sounds nice and neighborly. It took a while for me to realize that it was a technical definition. So thanks for the clarification there. And thank you to our three panelists. We're going to shift over and start to layer in some more perspectives now. I know, Ted, that you're going to need to jump off at some point. So thank you again for joining us. And what we're going to do is, and I see there was one other question about labels and glues, and I'm going to save that for the next panel because I think they'll be able to speak to it more directly. So without further ado, next up on our agenda is our Young Professional Spotlight. So one of our, I guess, focuses here in the SWANA Northern New England chapter is to draw young professionals into our industry. So in that spirit, we've set aside some time here to spotlight a group that's from upstate New York that's building a business around recycled glass. They are young professionals, and here to represent them is Jacob Kumpan. I think I got that. Am I close?
You did.
Jacob? Oh,
Yes,
all right.
you did.
Excellent. And his company is Claw Industries, and I will let you go ahead and share your screen and take it away, Jacob.
All right. Thank you very much, Abby. Can you see that all right?
There it is.
Perfect. All right. So my name is Jacob Kumpan from Claw Industries. And at Claw Industries, we process MRF glass into concrete. So what we do is we derive a product called Pantheon from MRF glass. And what Pantheon is a reactive cost-saving material for concrete producers. So MRF glass, as you see on the left there, has a bunch of contamination in it. We take that out and process it to what you see in the middle, which is Pantheon, and sell that to concrete producers, and they mix it in with their concrete. Now, as you can see, Pantheon is extremely fine. Just to put it in perspective, it feels kind of like baby powder. There's no grit to it. So to understand exactly what Pantheon is, you need to understand a little bit about concrete. Now, concrete, like you see in a sidewalk, is made of gravel, sand, cement, and water. The cement and water react to form the glue that holds the concrete together. Now, cement is by far the most expensive material in concrete. It makes up about 75% of the concrete producer's material cost. In addition to this, cement is also the most environmentally intensive material to create in concrete. For every 1 ton of cement produced, 1 ton of carbon dioxide is released in the atmosphere. So it's a huge polluter, basically worldwide. So Pantheon is a partial replacement for cement in concrete. That means the concrete producers can lower the amount of cement in their concrete mix and replace that portion with Pantheon. This not only increases the overall strength of the concrete, but lowers the embodied carbon and lowers the material cost. So just to kind of put a visual on this, the picture on the left is Pantheon being used in a ready-mix concrete truck. In this specific application, this concrete producer was trying to lower the embodied carbon of a concrete pad using Pantheon. The picture on the right is Pantheon being used at a precast concrete facility in Vermont. In this application, this precast plant was looking to increase the strength of some manhole covers that they were producing. Now, on the recycling side, we specialize in taking highly contaminated glass. Picture you see in the bottom left is MRF glass. It's about 40% contaminated. We regularly take this to about a level of 0.38% contaminated MRF glass. After this, we do some further processing to get that little bit of remaining impurity out and create Pantheon. Now, the reason we're able to deal with this highly contaminated glass is our process, which not only involves mechanical aspects, but electrical and software aspects as well. Now, we're currently scaling this process in Binghamton, New York. The picture you see on the left is our new production facility that we just purchased in June of 2021. And we've spent the summer outfitting it to actually produce Pantheon. We're now receiving MRF glass from recyclers that have this highly contaminated glass. Picture you see on the right is the very first delivery of MRF glass that we received at this facility. Now, one of the most common questions we get is how did we start Claw Industries? And myself and my two co-founders, Jack Lamrelia and Tanner Wallace, were interested in the recycling industry. but didn't really know where to start. So back in 2019, we decided to just call recycling facilities and ask for a tour. So on these tours, we learned about the different problems that recyclers face. And one of the ones that we heard all about all the time was that, glass is a hard material to deal with, and there's, recyclers have a hard time finding an end market for it. So we thought about it, and we wanted to find a market for this glass that not only could use the glass, but actually had a need for it. And there was a desire to get a material. So how we started was we took 5-gallon buckets of glass from a couple different recycling facilities and just hand sorted through it. We wanted to figure out what exactly this contamination was, why it was such a problem, and how we could effectively remove it. So we took our hand sorted glass and then went to different facilities that we thought used glass or used recycled materials in general. This included fiberglass facilities, people in the ceramic industry, people even in the tile industry. We eventually came across the concrete industry and realized there was a need for cement replacements in the industry. And so after some initial experiments with a recycling facility and a concrete plant, we developed Pantheon. At that point, we formed Claw Industries. So since then, we've raised over $300,000 in the past 18 months alone. This has come mainly from grants and business plan competitions that we've won. Now, we couldn't have done this without support from concrete producers and recyclers. This has really allowed us to take Pantheon out of the testing and demonstration phase and into the scaling phase. Now, the picture you see here on the left is Claw Industries team at the Binghamton Business Plan competition. And the picture on the right is actually the first commercial use case of Pantheon. In this specific application, a customer had called and requested to use for Pantheon their concrete to lower the embodied carbon of the sidewalk that they were installing. So moving forward, we're scaling Pantheon to meet the demand of both the recycling industry and the concrete industry. And to do that, we're looking for sources of glass, especially this higher level contamination of glass. In addition, we also want to hear about some of the problems that you are having with your glass, and basically how we can adapt our process to help solve those problems. And I wanted to put these two pictures on here because I thought they were interesting. The first picture you see on the left is the very first trailer full of MRF glass that we actually pulled home to sort out and use for our first initial experiments with concrete facilities. And the picture on the right is actually the most recent delivery of MRF glass we got at our facility in Binghamton, which was actually dropped off yesterday. And at this point, I'll open it up to any questions. I also put my contact information here as well. You can feel free to reach out by phone or email, whichever is more convenient for you. And thank you very much.
Great. Well, thanks, Jacob. That was a great presentation, a good quick snapshot of what you guys are up to and how you got here. I guess we do have a little time if anyone has questions that you want to throw into the chat. I think, while we're waiting to see on that, do you want to speak at all about, customers? Are you getting to, so you talked about needing more glass. Is that because you're seeing demand for your product on the other end?
Yes. So in short, yeah.
That's great. That's great. Is that like the household scale project that you showed, or is it coming at a greater scale?
Yeah, it's projects similar to that, as well as there's a lot of consumer demand for like the lower embodied carbon projects, as well as more on like university. I call them university style projects, projects that want like a very low embodied carbon. Those are kind of the early adopters, at least that we've seen in this space.
Great. Well, I think, why don't we, were you planning to stick around for the rest of the session, Jacob?
Yeah, absolutely.
Wonderful. So we'll have a little more time at the end. If folks have questions for you, if you want to chime in on any of the answers, please don't be shy. I could definitely follow up with the questions on the embodied carbon stuff. But why don't we get a few more voices in the mix here, and then we can talk more at the end.
All right. Sounds good.
Thanks a lot. Let's see. So up next, and we're just chugging right along. We are right on schedule, I think, maybe even a little bit ahead. So our second panel here is going to shift gears a little bit. We've been up in the sky talking policy, talking high level, and now we want to bring it down to the ground, as Jacob has done nicely for us, really look at, boots on the ground operations. What can we do with this glass? So our second panel is going to consist of glass processors who turn MRF glass into new value-added products. They'll speak about the work they do, the challenges and opportunities they see with using specifically MRF glass in their manufacturing. We're going to hear from Laura Hanneman with Strategic Materials. She'll be up first, and then we'll hear from Pat Grasso with Urban Mining. If you remember back to the start of the session, you saw a little bit of a clip from his facility. And then last, we'll have Rob Conboy with Glavel. And as I said, continue to put those questions in the chat, and then we'll bring everybody together at the end again to address those. So, Laura, we didn't get to do your tech check. I'm hoping that you're there.
I am here. I'm just turning
Wonderful.
on video. Hi, everyone. All right, let me do screen share. You wanted me to share, right, Abby?
That would be great. Yep.
Okay. All right. Just let me know when you guys can see this. Hopefully.
It says you've started screen sharing, but we don't actually see anything yet. Sometimes I forget to hit the little blue share button. I don't know if that's it.
All right, can you see it?
Nope.
Okay, give me 1 second. I think it's just taking a second to load. It is showing that I am sharing.
Okay.
I will double check it. Let's see, screen share, PowerPoint, share.
This is a new one for me. Oh, here it is.
Now, okay.
It's up. Wonderful.
All right. All right, well, thank you, everybody, and really good discussion. There are several things that in my presentation I had already planned to address, and I'm glad that there was a lot of good questions and things about glass recycling and some myths as well. So we'll just jump right in. Really briefly talk about Strategic Materials. Hopefully many of you in the area know Strategic Materials. We are the largest glass recycler in North America. We recycle about 3 million tons of glass a year. It's our 125th anniversary this year. So we have been recycling glass since 1896. You see in our little logo there, the 5 has a light bulb. We started recycling light bulb glass. That's how we began life for General Electric. We no longer recycle light bulb glass. We've evolved since then, but that is how we began life. We have nearly 50 locations across 3 countries. And the reason why recycled glass is in high demand, beyond the fact that it's replacing sand, which is a mined virgin material, it reduces manufacturing costs because of the energy savings, and also helps reduce CO2 emissions, which especially in some states like California, they are under really strict air permitting. So the use of recycled glass is really, really critical for those that are manufacturing new glass products. Again, touched on this a little bit, but why glass? Like, why should we care about glass? Why should anybody want to recycle glass or use glass? It is 100% recyclable forever. It's very similar to aluminum in that, recyclability story. It displaces virgin mine material, which takes CO2 to, mine that material and to transport that material, especially when there's a sand shortage or when soda ash is in shortage or it's not close to some of these facilities. It's adding a lot of CO2 emissions when you look at the whole life cycle. Recycled glass melts at a lower temperature. I think that was mentioned in the previous discussion, which is great. And there's some facts there for as far as how that calculation happens. But because of the melting at a lower temperature, that also helps extend the furnace life. So when the manufacturers, whether you're a fiberglass insulation manufacturer or you're making new glass containers, you're using a large furnace to do that, to melt the glass. And if you're not pulling materials that are hard, so we call it batch if you're 100% virgin material, if you're not running your furnace as hard, it's less maintenance, it can last longer. So there are some benefits on the equipment side for our customers in using recycled glass beyond just the permitting issues with the air permits. Because of recycled glass content in some of these materials, related to building materials, I called out fiberglass insulation specifically. It does allow them to be Energy Star certified and LEED eligible for some of the credits under those programs. And then from a consumer side, it's chemically inert, so it's not going to leach into your products. We do like to say that it's ocean friendly just simply because it's inert, and over a long period of time, it will become sand again. Wildlife doesn't ingest it like they ingest some other materials that end up in waterways or in the ocean. And for us, we focus on high value markets rather than low value markets that we consider less desirable. But we also appreciate the fact that there are a lot of options for glass. And we think that especially when there's challenges like in the Northeast, I know we mentioned the closing of the Ardagh facility, which was a close producer who was pulling a lot of recycled glass every single year. It's great to have options. So anything but landfill, we love. But we focus really on the bottle to bottle, which would be your glass container manufacturing, your fiberglass insulation, and then terrazzo flooring, tiles, countertops, concrete, which I know Claw had talked about, lightweight aggregate. And then low value for us would be more like your road-based aggregate. It's kind of like end of life. And then landfill cover is our least desirable. So moving through that, did want to address some myths. I heard a couple, and I think that there's a huge education issue around glass recycling as a whole, not just by region, and everybody's scenarios can be a little bit different with different challenges and opportunities. So understandably so, we hear these every single day. So broken glass cannot be accepted. We accept broken glass. We break it as part of our process. The only thing that we have issue with or concern with is really, really fine material like sand, only because we can no longer color sort it. So other than that, broken glass is perfectly acceptable to us and causes no problem. Mixed color glass cannot be accepted. We accept mixed color glass. There are certain regions or certain counties that will choose to do color sortation for a variety of reasons. From our side, we don't really need it to be color sorted. There are certain scenarios where if you are color separating, it might be worth a little bit more just because we don't have to run it through a certain process. But typically everything we get is mixed color. We don't typically get, color sorted glass. Glass must be washed and cleaned. I saw a question about labels and glue and all of those things. It's not a requirement. If you want to remove the labels, please feel free to do so, but it is really not a requirement for us to recycle it. We've got the right process to remove those materials in order to recycle them. Organics like food and things, they don't really cause a problem for us, but to me, it's more of a courtesy thing. You think about your MRF workers or workers for SMI, it just helps with odor and causes less residue issues. It's more of just, being considerate, but not a requirement. Glass contaminates other recyclables. This is a very heated debate sometimes. Our position is just single stream contaminates every material in the bin. So all those materials are competing with each other. The inherent benefits of glass are also sometimes the challenges with glass, the fact that it breaks. And we believe, working with organizations like the Glass Recycling Coalition or the Glass Packaging Institute, or even the Glass Recycling Foundation, which is the 501c3 nonprofit that I sit on the executive board for, can provide some best practices, some potential improvements, and potential grant money as well. Glass cannot be recycled due to China's sword policy. This just simply isn't true. Glass was never sent over to China. It is one thing that has been said on this call too is glass is heavy. Yes, it is. And that's why it's recycled domestically. What we have seen though is because there's a lot of I'll say challenges, but also like budget constraints and a combination of things of residents throwing things in their bin that they shouldn't. There's more materials in the stream than there ever has been before. Because there's not an outlet for some of those materials that were originally sent to China, it becomes a cost play, and sometimes glass gets cut because they need to save money. So it's not necessarily something that was sent to China, but has been sort of something that we've seen in the stream or in the decision-making process that has sort of, taken the hit. Glass has no value, or belongs in the landfill, or the glass of value has gone down. This is also one that, understandably so, there is some discussion about. Glass itself is valuable. The challenge that we have is when highly contaminated glass piles come to our facilities and look nothing like glass, that is a cost to us, not only to bring it into our facility with transportation, but also to process it with operational inefficiencies. And then on the back end, then if it's not something that we can recycle, that is even non-glass, because we also recycle aluminum and cardboard, then it's something that we have to take a hit on. So that's why we price glass appropriately. The more contaminated, the less value for that pile, and the least contaminated, higher value for that pile. There are no end markets for glass, and understandably so, this is a challenge for the New England area. All the more reason why we are supportive of having a lot of options. Anything but landfill, please. And so for us, today, I will talk about it in the next slide, I believe. Our end markets for glass in New England include container and fiberglass insulation primarily. Other applications for glass would be highway bead, surface preparation for an air blast abrasive or filtration material. And for us, demand exceeds supply in many areas. Like I said, New England's got a few challenges right now with glass that's non-deposit glass. I mean, it's important to make the distinction between curbside or MRF glass and something that's deposit or source separated. But simply talking glass nationwide, there are certain areas where we cannot get enough glass into our facilities to meet customer demand. So glass specifically in the Northeast, we operate in South Windsor, Connecticut. Hopefully several of you are familiar with our facility there. At this time, our facility only accepts deposit glass and source separated. We have partnerships with a couple of programs. One was with HRRA, and I think Jen Heaton-Jones is on the call. Recently launched a program in early September. I believe it's 14 drop-off sites. That could be wrong by a couple sites there. That's running in Connecticut. And then we also have set up an aggregation site in Middleborough, Massachusetts, where municipalities can come drop off their glass. We aggregate it and send it into our facility. And then it's typically food and beverage glass only at our South Windsor facility. Several of our other facilities accept more than food and beverage, not through curbside. Curbside is completely different, but directly into our facilities, we'll accept plate glass like windows, windshields, other auto glass, and recycle that as well. We do not accept MRF glass at this time, and this is why I'm reiterating why it's important to have a lot of options, because there are viable outlets for MRF glass in New England, and I think some of the other panelists will touch on that, so I won't take away from their presentation. We're constantly evaluating what makes sense, but the processing equipment and the way that we would set up our facility is different than what our South Windsor facility today can handle, which is just a cleaner stream of glass material. South Windsor facility services two primary markets. Both have a strong end market demand, both container and fiberglass insulation in New York. And then we do send some material outside of the region in order to meet that demand. But overall, we have a strong demand and we need more glass into South Windsor. I think this is my last slide, but wanted to talk a little bit about bottle to bottle. Wanted to focus on that as my section so that my fellow panelists can talk about their section for glass and where the glass goes in the region. But the interesting thing about glass, not only is it 100% recyclable forever, basically there's no loss, and in using recycled content or recycled glass, melting at lower temperatures and energy savings. Typically we see if it's a clean glass material, it can travel up to 350 miles and still be carbon neutral. And anything beyond that, it's a little bit more of a challenge, but it's not too much of an impact, taking into account the savings in the production side. But it starts with you as a consumer. Hopefully you buy your favorite products in glass, you enjoy those products, you put them in your recycling bin, or you're taking them to a drop-off program or a dual stream pickup. From there, it's going to be sorted if it's going through curbside. And then hopefully it's coming to an SMI facility where we would process it and get it to meet specifications to become cullet. And cullet just means furnace ready recycled glass. So just broken glass isn't always cullet. It has to actually meet the specifications to go back into the melted. From there, it is going back into glass container manufacturing or fiberglass insulation. If it's going into glass container manufacturing, it's going to be filled by a brand. It's not typically filled where the bottles are made, and then back on your shelf. And that whole process takes less than 30 days. In fact, we've done an exercise with all of the stakeholders in the glass recycling value chain in the room at one time, and we said, how long does it take for you to pick up curbside? How long does it take for you to sort it and get it to the secondary processor like an SMI, et cetera, on down the line? And they came up with 17 days. So for us, bottle to bottle is considered more of a highest and best use behind refillable or returnable programs. But when there's glass challenges with contamination and maybe distance from a processor, those other outlets to avoid landfill are really, really critical. And we're obviously supportive of those as well. This is my email. If anybody has questions, obviously I will stick around for Q&A, and appreciate the opportunity to talk a little bit about glass, and happy to answer any questions and pass it over to Pat, but Abby probably is going to be the moderator here. So I'll pass it back to Abby.
Thanks, Laura. No, that was fantastic. Thanks for layering in your perspective and helping to clarify a couple of the earlier points. So yeah, you're right. Our next speaker is going to be Pat. And Pat, I'll let you hop in, share your slides, and take it away.
All right, you seeing slides there?
We are.
Okay, good afternoon, everybody. Thank you, Abby, and thank you to everyone on this call today for having me. Again, I'm Patrick Grasso. I'm a partner in a company called Urban Mining Industries. We're making a product called Positive. We've been making it now for about, 12 or 15 years now. I will tell you more about that. It's basically a ground glass pozzolan. And first, I guess we should tell you what a ground glass pozzolan is as well. That image above around the logo is the final product we're making. So what's a pozzolan? Basically, it's a fine powder, as I think Jacob started to explain before. By itself is an inert material, but when mixed with hydrated with cement and water, becomes cementitious. It in effect becomes more glue for cement and making concrete. They're essential in making high performance, more durable concrete. The Romans and the Greeks have used it for over 2,000 years, and as you can see, many of those structures are still standing today. What we're doing is really providing a solution for three industries. The glass recycling industry, we've heard a lot about the challenges today. We can just briefly touch on them again. We'll talk about some of the cement concrete industries, and Jacob talked a little bit about that before, and what's happening in the pozzolan industry, which this product is really a substitute for. We opened our first full-scale plant in Connecticut in January of this year. We had been operating a product validation plant for about 10 years upstate New York. Actually, I think Jacob's college did some early testing with us over the years with some other products as well. So lots of good test data and history. We'll tell you more about where it's in use now. We spent 4 years developing a new ASTM glass standard, which makes it much easier for architects and engineers now to specify the product. The photo on the top is really just, some of the dirty MRF glass working its way through the system, and the bottom is the finished product that we're shipping out to various manufacturers, of anyone that's basically using cement in their manufacturing process. I think enough people have talked about the challenges of of glass recycling, and as Laura did as well, and where we can complement some of the things that I think SMI is doing, taking some of this other glass in the region that is a bit more challenging. The photograph on the right is a typical, the daily loads we're taking in at our plant. And you can see the challenge why most of it has been going to landfill and why it has been so challenging to clean and process. If folks have talked about the color segregation needs, the need to eliminate ceramics and porcelain, and the sizing minimum required for color sorting. Green glass remains limited. CRT panel glass is really non-existent. And again, Jacobs University did some testing with us where we actually created a solution for CRT panel glass as well. And as a result, as we saw in an earlier slide, most of the glass is still going to landfill. Positive can really take any color size glass. When you grind it to such a fine powder, clean it and grind it, it becomes white, even though it's a 3-color mix. We do, as I mentioned, that we have a solution for non-existent home for CRT panel glass, plate glass, and demolition glass as well. We'll talk more about that as we go. And again, I think Jacob may have mentioned, creating a ton of cement creates a ton of CO2. That's really the big black eye for the cement and concrete industry. Yet it's the biggest building product we use globally beyond water. So it's not going away. It's a critical component of construction. Positive can replace up to 50% of that cement in a concrete mix and reduce that carbon footprint at an almost ton for ton basis. We'll talk again more in a later slide. The pozzolan industry, historically the biggest pozzolan had been fly ash, and we all know what's happened to fly ash nationally, and particularly in our region. I think we're down to 1 coal burning power plant in the entire Northeast. The shutdowns and conversions have significantly reduced fly ash, which again has historically been that critical pozzolan component that's made a stronger, higher performance concrete. And Positive fills those voids with a really a better performing alternative than what it's been replacing. The environment, the benefits are really 2 major benefits: environmental and performance. We talked a little about the carbon footprint reduction. You can take any glass, again, nothing needs to go to landfill, and we can take ceramics and porcelains. It yields a whiter, brighter product. You can see in this photograph to the right, the top portion of that photograph has Positive in it. We did 2 full city sidewalk blocks in New York City. The New York City DOT had a significant interest in reducing heat island effect in an urban area, and you can see how much brighter that makes a sidewalk and what it does to brighten those walks. I think the story for all our communities is it's made and used regionally, and it's made from regionally harvested post-consumer glass, minimizing long-haul trucking along the way. On the performance side, if you're a developer, architect, or engineer, it creates a better performing and longer lasting concrete, and we have tons and tons of test data to support that, independent test data. It prevents efflorescence, which is that white powdery stuff you see on cement. It's kind of unsightly as a result of the concrete mix aging over time. It reduces water, which makes the concrete stronger. So it gives those that need high performance concrete or stronger concrete another advantage. But the big thing it does, it reduces the chloride penetration. It reduces moisture penetration. Chloride basically is road salt at the end of the day in the Northeast. That's what's really been the killer for our concrete and the rebar you see in that photograph in the right. And that's why we've got to replace concrete, sometimes 30, 40, 50 years after use. And this has potential to expand that life significantly, and in doing so, significantly reducing our infrastructure costs. Again, we talked about, the big black eye that CO2, that cement has, basically producing about 7% of the global CO2 annually, and has been the big challenge for the cement industry and the concrete industry. We had Climate Earth do a life cycle assessment for us, showing that producing Positive has a footprint of about just 5% of that of producing Portland cement. So it's almost a ton for ton savings of putting a ton of Positive in place of a ton of cement in a concrete mix. Our plant in Connecticut is equivalent about taking 8,000 cars off the road with its carbon savings. I echo what Laura said about carbon savings and the impact that all of us have in various ways. Laura mentioned the benefits of putting it back to bottles and fiberglass and saving about 1/6 of a ton when used that way. If you just want to measure CO2 savings, this has the biggest impact because of the heavy carbon footprint of cement it's replacing. So while, and we are very supportive of every use of glass, including going back to bottles of fiberglass, from a CO2 greenhouse gas savings potential, the biggest impact is to put it into concrete and to replace cement. It's orders of magnitude, it's 5 times more impactful than any of the alternative uses we've been talking about. So from a carbon perspective, I know it came up early in the conversations. It's one of the best stories to be telling, in addition to kind of extending its life and providing a solution for the unwanted MRF glass in our region. Again, as I said, it's been around a while. Before we opened this bigger plant in Connecticut with our validation plant, we were able to get it in use as far as Vancouver. We've got it out in Google's headquarters on the West Coast. We've been sidewalks throughout New York City. We're probably in over about 10 million concrete blocks already, including all the Second Avenue subways. We're in, you can see those pre-stressed concrete planks. We'll talk about permeable pavers and high-rise pours as well. But broad use, currently our plant in Connecticut, we have either used or have committed to use of over 30,000 tons of yards of concrete that'll have positive in it already. This is one of our favorite stories. We took the window glass from the UN Plaza, processed it into positive, gave it to Unilock Pavers, and it sits in the pavers you see out there outside the front entrance to the UN. A great kind of, closed loop story here environmentally with glass. This was the big turning point for us. The first high-rise pour that used ground glass Pozlon with the Durst organization. We've used positive throughout this project. The first high-rise pour in New York City, in the country, and maybe the world, I'm not sure. That ground glass was used. The Durst organization is hoping to do the entire next tower out of positive as well. So that was really kind of the big turning point that opened the doors and took it beyond block, pre-stressed plank, pavers, et cetera, sidewalks. Some places where it's already in use in our region, the ESPN headquarters, the apartment project here in Stamford, UConn's operational facility here in Connecticut. A new school in Darien is using it throughout the new school construction. It's underway right now as we speak. We're proud about the recognition we've received so far. We've won the Building Green top 10 building products twice now, a national award. EPA has given us their highest award that they can give. And last year, the Northeast Recycling Council was kind enough to give us their 2020 Environmental Sustainability Leadership Award. So we're excited and proud of all of that. A couple of photos of our plant, again, here in Beacon Falls, Connecticut. On the left is our load-out facility here. Materials basically comes in by dump truck, the raw material. It goes out in tanker truck and finished product to concrete manufacturers. Photos on the right and below are basically more photos I think you saw in the video as well of our part of our plant. So in summary, what does positive provide the communities? It's a cost-effective, large-scale solution for glass. So it's an alternative for glass. It's a real alternative to costly and diminishing landfill options. It creates a commercially viable and low-carbon solution for concrete that's actually better performing and longer lasting. And it's a great environmental story for all of us to be telling in our communities. Feedstock is sourced regionally, finished product is made regionally, and it's used regionally. And every time we build one of these things, there's significant capital investment and job creation as well. Again, I kind of went quickly through this because I know a lot of the points got covered by others. I am happy to talk more after we get through this. I encourage you to take a look at our website, positive.com. I'll make myself available later and after this call for any questions. Thank you.
Great. Thanks so much, Pat. That was a great overview. It dovetails nicely with what Laura presented. And I do see we're getting a lot of questions in the chat. I'm going to keep an eye on that, but layer in our last speaker here so we can really have the full rounded out perspectives here, and then we'll put you all back up for questions. So Rob, if you are out there.
I'm out here. Can you hear me?
I hear you, I see you, and
Very good.
we're gonna have to kick Pat off the screen share to.
Can you do that? Yeah, I'm not sure actually how to get myself out of here now. I lost my control of my.
I have to say, it's pretty amazing to see how far Pat's come. I think he and I first met at Greenbuild in LA 5-6 years ago. And I had a handful of foam glass gravel that I had just gotten from Europe. And I was walking around Greenbuild to see if there was going to be a market for foam glass. And Pat came up to our booth. That was at the time I was doing financial products for green building, and he and I chatted about what he was doing and crossed paths in New York a few times. But so exciting to see the work that you're doing, Pat, and it's such important work when you think about the carbon impact and the importance of helping solve our carbon problem.
Thank you. And thanks, by the way, to Laura and SMI, who early on got us started with some early testing. So it's kind of full circle here with everybody involved.
It is a small glass world, that's for sure. And hopefully I'm presenting. Can you guys see my presentation?
Yeah, looks beautiful.
Awesome. Well, thank you so much, Abby, for having us. And without further ado, I'll kind of dive into Glavel. So first off, just a brief history of Glavel. I kind of mentioned that I bumped into Pat about 6 years ago at Greenbuild in LA. I was first introduced to foam glass gravel on a trip to Europe at the Passive House Conference in Darmstadt. And from that time forward, I began the process of trying to stand up manufacturing of foam glass gravel in the United States to service North America. The first step for us was to help validate the demand for the product. So we actually began importing foam glass in 2019 just to start seeding the market and demonstrate the demand for the product before we actually stood up our first manufacturing facility. We're really excited that our manufacturing facility will be operational in Q4 of this year. And it's been a long time coming, and we have a lot of anxious customers that can't wait for us to get the product on the market. Foam glass broader history is actually, over a couple of decades long. Foam glass gravel has been on the market in Europe for over 25 years. And that was one of the things that actually really attracted me to foam glass gravel, was that it had a proven track record. It wasn't a science experiment that I had to hope to prove that it performed the way that it should. There was a long history that we could leverage as we tried to stand up our own manufacturing here in North America. But briefly, we've all sort of seen what the glass looks like. This is actually Chittenden County solid waste glass, which is kind of cool. The glass then is turned into a powder that we've sort of seen with Pat and Jacob. It's a similar process. But to our glass powder, we then will add a foaming agent. So foam glass can either be produced with a dry method or a wet method. Both methods deliver a wide variety of R values and compressive strength for various applications. Very versatile in both the wet and the dry. The end product, there really is no difference or discernible difference between how it was manufactured, wet versus dry. And it's just really kind of a choice that the manufacturer makes in terms of how they want to transform the glass into the foam glass gravel. In Europe, it's a mature market to some extent, and about half the sales of foam glass go into infrastructure and half go into buildings in the built environment. So the infrastructure applications include road beds, embankments, bridges and tunnels, pipe insulation. It's a great lightweight fill. So our values can range of the product from, in the high 1.7, 1.8, down to, 1.1 or so with a more dense product for infrastructure. We're focusing on the applications in the built environment. It's a wonderful solution for sub-slab insulation, allowing customers to eliminate the need for a gravel, 3/8 gravel as a drainage layer, and then the insulative layer. So on an installed basis, it's actually a cheaper product than conventional means of insulating below slabs for buildings. And with issues that have happened in the supply chain for foam board recently, we're even more cost effective and readily available. On the built environment, there's also applications for green roofs. Because of the compressive strength of the product, it can be used under footings and used for frost protection. I often have on my desk this reminder that back in August of 1977, the EPA recommended that we make foam glass from our waste glass. So, it's taken about 40 years, but we've finally gotten around to it, which is great. I found this great little video to give you a sense of what the manufacture of foam glass looks like. So hopefully I will play it. Hopefully that's not too loud.
So Rob, I'm not actually hearing anything. Is it important that we hear something?
No, it's just it's Euro music, but that's good to know because the next video I'm going to show is actually from a customer in California. So I should figure out how to make sure we get the audio playing. So you can see the glass powder that's being fed into a kiln and heated to about 1500 degrees Fahrenheit. And, it starts out about an inch thick and foams up about 4x. And what crumbles off and tumbles off is the finished product. It's incredibly versatile and really easy to use on site. Large manufacturers in Europe, they create these large piles and deliver to the built environment, but also for infrastructure projects as a lightweight fill. It's a great solution. All right. Oh, come on. So one of the things that, as we looked at foam glass gravel and wanted to take the product into the future, what are the things that are critically important as we establish ourselves as a manufacturer? And obviously there's the need to take glass that may not otherwise have value and upcycle it into a high demand building material. But we also took the added step of, in 2019, we decided to electrify our process. So most foam glass producers burn quite a bit of natural gas to create the foam glass gravel. And we committed to electrifying our manufacturing process to arrive at a very low embodied carbon building material. Our utility partner, Green Mountain Power, will be announcing soon that their electrons are 100% carbon free. While they're not all renewable and there's sources of energy, including nuclear, carbon really is the our focus. And lastly, as we build our company, we have a deep commitment around social justice. The Biden administration has highlighted the need to, as we transform to a more climate sustainable future, that social justice issues have to be addressed as well. I'm sure many of you know a few weeks ago, I guess maybe now a month ago, the IPC report that recently came out sounding the alarm bells around carbon. And it was great to see how well Pat highlighted the importance of the low carbon solution that glass can represent. We have a number of existing technologies that will really help us reach our low carbon future goals, and urban mines and Glavel are at the forefront of that. When we look at our built environment and how we're delivering our green buildings, it's often on the foundation of some really nasty chemicals and a lot of petroleum in the form of foam board to arrive at the insulative value required to achieve the energy efficiency goals of the buildings above them. And foam glass gravel allows you to deliver on that promise of the energy efficiency without having to use a bunch of petroleum and nasty chemicals. Our plant, we're estimating once we're producing with our 2 production lines on an annual basis, we will be removing 5,300 cars will be taken off the road. I figure we now soon will have to have an asterisk for, not electric cars, obviously, which is kind of funny as we move forward with electrifying our transportation in important ways. And this gives you a sense of the embodied carbon in existing materials and the importance of focusing on the built environment and the embodied carbon in the materials that are used to build our buildings. This is a typical detail for subslab insulation. On the left, you see the aggregate used for drainage, and then the foam board used for the insulation below the slab. And the advantage of kind of one-stop shopping with foam glass gravel allows builders to realize the savings not only on the first cost, but also in terms of the time to install the subslab insulation. And this shot gives you a sense of some of the projects that we've done in New England. This is in upstate Massachusetts. This was a prefab Bensonwood home. The customer was buying a low embodied carbon healthy home from Bensonwood and wanted to use foam glass gravel as their subslab insulation. This is the Capital One headquarters in Virginia. In the middle of COVID, we delivered many containers of product for their green roof that they have on their corporate headquarters. So just giving you a sense of some of the applications that we saw since we've been importing. So now I really want to show you this, and we got to figure out how to get the audio going. It can be a bummer if you can't hear it. Can you guys hear the audio on that?
We're not hearing anything. A helpful attendee in the chat said when you share a video, there's a small box you need to check to include the sound.
Small box I need to check. Bum, bum, bum. Do they know where that small box is?
So, and we would welcome any other clues you may have. I know so I showed some videos at the beginning, Rob, and I had to go to like click over to the I hit share and I had to click to advance and I had to find it was a different process entirely. So I'm not going to be helpful. Let's see. It only shows up when you're sharing. I think it's in the lower left. So maybe try again and see if you can find it.
Let me see, stop sharing, share. Ah, there it is, share sound. Awesome, thank you. It takes a village to do a Zoom presentation. Awesome.
Hey, it's Andy Pease, Inbound Screen Consulting. I'm here again at the Los Robles site. We're talking with Mike Horgan about the foundation and the insulation and an awesome material called Glavel. And the things that I'm excited about for this part is that, one, we just want to talk about the importance of having insulation under the slab for this project, but also a really an important way that we're trying to use less foam and looking for a solution to be able to insulate, use less foam, and even save some money. All right, so Mike, let's talk about what is the product first? What is this thing that we're talking about?
It's called Glavel. This is it's a recycled glass, 100% recycled glass aggregate. It almost feels like pumice, like a sponge.
Like super light.
Yeah, it's really light. Structural engineers loved this stuff when they got to see it the first time. So it comes in about a 3-inch rock, 100% recycled glass, and it comes in 700-pound bags, Hannah, right? And we just unloaded the bags off a truck. We dumped them inside the slab. 2 of us spread almost the entire slab in half a day, compacted it all in half a day. So it went down really quickly. It's very light. We moved it around with a push broom and a rake. This provided a few advantages to us. We needed to have an insulated slab in this house in order to pass through PHPP, the Passive House Planning Package. It's also really advantageous to have an insulated slab in this area because we actually it's fairly cool here at night. I mean, it was in the 30s, high 30s last night. So floors are really cold in the morning, and this creates a great amount of comfort. So what this does is it gives us a thermal break in between the ground and the slab. So the little air bubbles inside the Glavel will cause temperatures to stop moving from the ground into the slab and creating that cold floor space. Sometimes when you get new products on the market, they come with a bit of a cost measure, a bit of a learning curve. The learning curve for this was basically non-existent. We brought the concrete crew out here and they learned how to do it 100 times faster than we learned how to do it. And then cost-wise, we had planned on $2,500 worth of gravel stone aggregate and another $1,500 worth of a rigid foam insulation that Hannah and I were going to put down ourselves. So this actually shipped to us. We shared a shipping container with 3 other projects in California. This was $3,100 delivered. So we got our aggregate and our insulation, and our install time was, I think, less than what putting an aggregate stone down would be. So fed a bunch of birds with one scone. Yeah.
Excellent, thanks.
Cool.
Awesome. Why is it not advancing? Oh, there we go. So yeah, this is the facility that we are going to be operating out of in Essex, Vermont. It's a 25,000 square foot facility. When fully operational, we'll have 2 production lines as well as glass processing. Our capacity per year will be taking in somewhere between 15 and 20,000 tons of glass per year and producing, around 150,000 cubic yards of Glavel. And like I said, our first production line will be operational later this year, and we'll be bringing our glass processing online hopefully mid-year next year to do our own processing of glass into glass powder inside our production facility. So that is what I have, and I think we're ready for Q&A.
Wonderful, great, and thank you. A little tech help from the audience
that was awesome.
was fantastic. So thank you for that, Ian. All right, so I'm just gonna tell you guys, I got so interested in what you're saying. I wasn't trying to get organized with my questions. So hold on a second. This is great. So Bob's going to be sifting through the chat for us, I believe. But in the meantime, I'm going to throw one out here. I guess just to get us started, I want to kind of throw back to a question I asked of the first panel, which was, is glass recycling a climate solution? Does it have a climate benefit? Each of you guys spoke to the climate benefit of what you're doing. Is there anything you want to add that, as you listen to their answers, was there anything you thought we were missing that you wanted to just elaborate on or point out here?
Yes, from my side, I was just going to say really quickly, and then I'll turn it over to you, Pat. There's not much for us to add from our side other than I think that some of the studies that have been done about glass versus other materials don't account for the entire life cycle analysis. So it's one of those things that I know some of the trade organizations are working on, in comparison of virgin vine materials and the CO2 emissions that go into that versus like drilling for petroleum. And then also the process of where it's going and the impact, whether the application is back into bottle or something else, and what the implications are there. And I think it varies. I think the life cycle analysis varies by region because it really depends on those like virgin materials that it's displacing and what that actually means in that calculation. So it becomes very complex. But other than that, I mean, we do our own calculation for suppliers to say, because there are, concerns glass is heavy. And if we move it here, what does that mean for us? And we're working on our carbon emissions footprint or our carbon footprint as a city. And so we can provide data of how many emissions were saved or, where it's going and how it's being spent. So that's it from our side. Pat, I know you were going to jump in. Go ahead.
No, it's good. And I just add to what Laura's saying. I can't emphasize enough the potential impact that this could have on replacing cement because it's its biggest challenge to that industry right now, the biggest black eye it has, and it's very powerful in terms of its reduction. The heat island effect, again, I think is worth making the point again, particularly in urban areas. It significantly lightens the color of cement and concrete when it's used, so it reduces heat temperatures in our urban areas. Harvesting, manufacturing, using it locally to save trucking costs, I think is a great story again. And to use it all. I mean, nothing needs to go to waste. I mean, again, certain process, there's a certain size you can color sort down to, and then you can challenge what to do with the rest. And we can take it all. And so I think the combination of all that in coupling with what Laura said, I think is, makes the point. But there's a great story for glass, and we all need to just tell it more. I think it's a great product, and consumers want it. At the end of the day, that's really the punchline. People like glass, and I think we've got a good story to tell with it now.
I just want to add that because of the properties of glass and the compressive strength that we arrive at with the installed foam glass gravel, we can actually eliminate some concrete. So the thickness of the slab allows for engineers to actually eliminate some concrete altogether. So you eliminate some concrete and then you follow in with Jacob and Pat's product. You're looking at significant reduction in CO2.
Just to build quickly off what Pat and Rob were saying, the reason that like cement is becoming such a black eye is that the concrete industry is starting to come under regulation from a lot of states in the Northeast. Basically, it's kind of been under the radar how big a problem cement is. And now, there's been a lot of focus on power, and there's starting to be a lot of legislation switched, not just in New York, but a lot of states around. So it's definitely going to become more and more of an issue.
Right. It does sound to me like maybe the team over there at EPA needs to work on their WARM model. We need some more detail on glass recycling options. Maybe we'll see that sometime. We have a question from, I believe it says, as a legislator, are there examples of how governments got positive, or let's fill in the blank with the other products here, spec'd into building projects? Why don't we start with Pat?
Sure. Yes, and again, New York City DOT would be a good example. I think they're continue to be on the forefront of wanting to use more of it. The state DOTs, again, I'm not sure where this question came in from, which state, but we're strongly encouraging all state DOTs to continue to really focus on this. We're spent a lot of time. We're already approved by Florida DOT. We were years ago in the New York State DOT specs. Connecticut DOT is actively now finishing its review and approval. Mass DOT is beginning its testing now. So I would encourage that, particularly at the state level. Anything that is municipal or kind of road related probably falls back to DOT approval. So getting them on board in your state early on I think is helpful. If it's a specific project with a building project or anything else in your town, your architecture engineers should have heard about this by now. If they're not, get them in touch with us and we'll guide them a bit more and how to use it and specify it. But there's enough examples out there. I think we'll get your professionals comfortable that it should be pretty easy to specify for municipal projects.
Rob, do you want to pick that one up too? Anything on your end?
Yeah, I would, we've seen lots of DOTs looking at and specifying foam, glass, gravel, but also as municipalities start looking at and refining their building codes and weaving in requirements around the embodied carbon for the building materials is one of the areas that we're really excited to see coming to the forefront. And then generally speaking, the building codes and energy codes aligning so that there's more demand for or increased requirements around the insulation below the slab is great for us.
And I think a lot of state agencies are also legislative arms are pushing for low carbon laws. New York State spent a significant amount of time getting something through. They got a little watered down, but is a good start. New Jersey is pursuing that now, and other states are thinking about it. And so on that front as well, on a more holistic approach, encourage low carbon use, low carbon products as part of that.
Jacob, do you have any perspective to layer in here?
Yeah, something that we've seen, at least up here in upstate, that's worked well for us is kind of bringing the end user and in our case, the concrete producer into the conversation as well, not just the architects and the engineers, because they have a lot of say on how these projects go as well. And, selling them not just on the embodied carbon benefit, that this is actually giving them a stronger product has been, getting their support helps check all the boxes for the project so there's not pushback throughout.
Great. And Laura, this is, I don't know if there's any parallel question in your world or if we can jump to the next one.
Yeah, I mean, the legislative side for us is really more around bottle bill and landfill bans or 80-20 rule at the MRF or ABC permit required for recycling. So it's more on like sort of the inbound supply side, not necessarily the application side for a DOT other than minimum recycled content. So there's not a lot for me to add for that question.
Fair enough. Fair enough. The next question sort of gets to, I think, more of a performance question. It's does Pozzolan and Pantheon increase the abrasion resistance of concrete?
Jacob, you want to speak to that?
Yeah, so in general, basically any type of Pozzolan, positive, Pantheon, or flash or slag, some of the other alternatives will increase the overall strength of the concrete. A lot of that to do, basically I kind of have like an example of concrete here. The material size or the particle size on Pantheon and positive fills in the voids within concrete since it's a finer particle size than cement. So that's where you are able to get some abrasion resistance.
Right. And it's a hard material. It's a very, a high mold hardness factor. We've used it actually. We've made positive industrial fillers as well. We put it in paints. We painted 25,000 square feet of Westchester County's environmental offices with it to create a more, a strong abrasive resistant paint as well. I'm not sure if we have any test data, but given the wear that I'm sure Laura will attest to and others that have handled glass, the wear on equipment shows that it's a very hard material and very tough on equipment. And I think carrying that forward on concrete, I think it's been asked to be used. We've had some MRFs wanted to use it for their tip floors because, because of the stronger nature of it. And as Jacob mentioned, that a tighter void, lesser voids be the stronger concrete and the more durable concrete. So I think the answer is yes. I'm not sure how much test data is out there that's proven that point, but I think there's enough anecdotal information to suggest that is the case.
Great. And that question was coming from Al Sabino with Casella, so that may be where his mind was at. Well, you might be getting a call later. Question for Pat, does the powdered glass go out of the facility as a liquid or dry? Just wondering, since you said it goes out by a tanker truck, which made me think it might be mixed with water.
It's a dry powder, and it basically, if you've seen cement tanker trucks on the road, they kind of look a little bit like a milk truck, but they basically have funnels on the bottom for the powder to drop out of or get pumped out of. So no, it's a dry powder is the answer.
This is for Rob. Will Glavel be using MRF PGA to make gravel?
Yeah, that is our plan, is to bring in PGA for our plant to be processed. So.
I think you touched on the timeline for that, Rob, but could you say
Yeah,
that again?
it should be,
Estimate?
you know, we're looking at Q2 of next year is our plan. So very quickly, we want to be processing our own glass.
Abby, if I could, I want to go back to a point that someone made. Maybe it was Eric earlier about, you know, using glass as an aggregate or sand. Yes, it can be, but it should not be used in a concrete mix itself, because at that size, it does cause some issues called alkali sulfur reaction, which is deleterious to concrete. So yeah, yes, it has a lot of applications in sand and gravel, but should not be used in a concrete mix at that size. It really has to be milled to a very fine powder so that this chemical bonding reaction could occur. So that's my only word of caution to the group, and maybe just a point of, you know, just clarification to Ted's points. I'm sorry, to Eric's points.
Great. Also, going back to the earlier questions, I know there was one about labels and glue. Laura, you addressed that in your slides, but I guess Pat, Rob, Jacob, are labels and glue an issue? Do you need people to take those off, or can you work with those?
Jacob, go ahead.
I could speak to our process specifically. That doesn't cause an issue for us. That's something that we deal with and expect. So.
Yeah, we've obviously spent a significant amount of money to create a pretty extensive processing line to clean it. So yes, by the end, the process of glass is, the ASTM standard is 99.5% pure glass, and we're down right now to probably 99.6 or 7% purity. So all of that gets abraded off through the process typically. Laura, I'm sure, is dealing with the same thing in her process as well when she's taking bottles into her system. It mostly gets abraded off through the process from beginning to end. Laura, please feel free to expand on that.
No, that's accurate. I mean, when we break the glass, the label typically comes apart. We use vacuums or blowers to just basically push the label off. There's not usually a glue problem. Usually it's a standard glue, or the glass has been sitting somewhere, or it's already gone through a MRF. So it's really not an issue for us. The only downside is the paper. Obviously, because of the form that it's in, we can't recycle it, but it is biodegradable for the most part. So other than that, it's really no issue for us at all.
Great. So if anybody's been trying to get their spouses to peel labels off of glass, you can stop doing that now. Another question for Laura, you talked a little bit about specs and sort of, different grades of glass and how the pricing is different depending on what it meets. I guess I'm curious, how much difference is there? How much space is there between, kind of the best case, highest MRF glass that you can see versus a bottle bill type glass?
It just depends. It depends by region. It really is. So what we do is we do inbound sampling. So if we're getting glass into a facility that is MRF glass, we take a bucket sample, we analyze that, basically do a short audit and a calculation and say, what's in it that's glass, what's in it that's not. And it's everything from NGR, which would be your non-glass residual, your fines. If it's the winter time in New England and there's a lot of snow, then the moisture is an issue for us at times. And so if it's more glass in the pile, it's worth more money. If it's less glass in the pile, it's less money. So, the swing could be anywhere from $20 a ton to something higher. There's so many regional sort of considerations. Some of it is logistics as well, and who's actually paying to bring that material into the facility. If it's something where we're arranging transportation, then obviously that's a cost for us to move trash around and not glass around. So it's just an economics play. And we work really closely with a lot of our suppliers, especially when it comes to MRF glass, to say benchmarking sort of metrics. This is where you are. These are some things that we would love to come see your MRF and say, these are things you might be able to improve on. This would be your payback period. Or maybe it's something as simple as putting a magnet in the process rather than a full investment. So it just varies, and the more glass, the better. Deposit glass is obviously very clean stream for us, and I think everybody would agree that deposit glass is high volume, high quality material.
All right. I guess a similar question for Rob or Pat or Jacob. Do you, on the inbound side, do you have multiple specs with different price points, or how do you think about that?
Yeah, I think I'd maybe again, I would echo what Laura said. We have a matrix basically, and ours is really more a function of cleanliness and moisture content. So sometimes loads, come in pretty wet, and it's just extra work to separate the material. But it's again, it's a math game, as Laura said. It's just trash. Whether you keep the trash or we get, have to deal with the trash, somebody's got to pay for it. Whatever the number is, 80, 90, $100 a ton or something. It just takes away from the economics. So the cleaner it can be for all of us coming out of the MRF, the better economics for the MRF. It's really no more complicated than simple math.
Yeah, I would agree with that. I apologize. I have a 14-year-old son who was frantically calling while we were presenting, and I had to make sure that the house wasn't on fire. But yeah, very similar sort of constraints around as we look to design our glass processing. How are we going to manage the winters in Vermont, and what glass looks like in the winters is really one of the bigger issues than anything else.
And are you that far along, Jacob, where you're working on your price matrices, or is that a little bit further down the road?
Yeah, that's what we did for that delivery that we showed in the presentation. But for us, we still have that matrix, but we are really focusing on stuff that is of a higher contamination level. That's what we're working on taking first, just because we know that's the hardest for really anybody to deal with. So that's kind of like the target we're focusing on.
There we go. I'd see Al confirmed that he was thinking about tip floors for transfer stations and MRFs, and you can read his comment there, but he likes this idea of being able to say that the MRF's floor is partially made of the recycled glass. So I'm with you there, Al. We might have a follow-up there. You guys have touched on this a little bit, but I'd love anything where you could elaborate. Are there policy changes beyond what we talked about already in terms of specs and stuff that would help ensure that your facilities succeed and become a long-term feature of the recycling infrastructure here in the Northeast?
I'll chime in really quickly. For us, we work closely with NERC, the Northeast Recycling Council, and I think Pat is also involved. Rob, I'm not sure if you are, or Jacob. One of the legislative pieces is minimum recycled content. It creates demand. It justifies investment for us to expand potentially to meet some of that demand. It's a sensitive conversation for us too, though, because our customers don't necessarily want to be told how to run their business and what the requirements are. And given some of the challenges in New England, it's also understandably a little bit concerning for our customers in order to be held to a certain standard potentially through legislation. For us, beyond that, I named a couple of them, but other states that do things that work really well to make glass recycling work, at least bottle to bottle, is ABC permit law. So in North Carolina, anybody who holds an ABC permit is required to recycle their core recyclables, so glass being one of them. They're obviously not a deposit state. One thing unique to New England is a lot of bottle bill, which is great. I think that actually really does help the system. And then the supporting markets like Jacob, Pat, and Rob have that are focusing more on that MRF glass that doesn't really have a home today really balances out the entire system, which is really critical. We've talked about the 80-20 rule where 80% from a MRF needs to be recycled. The state of Wisconsin has a landfill ban. It's not technically a ban. I've had other people say it's not a ban, but they should do everything they can to recycle their core recyclables. And if they can't, they need to get a waiver from the DNR in order to send that material to landfill. But those are just some quick quick examples from my perspective. Love to hear from the other panelists.
Oh, and Laura made the point that sometimes, I mean, the recycled content is a good idea, but it is sometimes painful for certain clients that just because of limitations, access to glass and product and the like. We're more in the camp of a more holistic, just, you know, laws that encourage recycling of glass in some form or fashion, to have it have a home, whether this was us or Rob or Laura's clients or the like at the end of the day. I think is maybe a more holistic approach on that. We'll continue to push low carbon concrete builds as best we can. And I think the other thing is just really having our state agencies enforce the recycling laws that are on the books. I mean, I think, you know, everybody's turned a blind eye for private time about where glass goes and the like, but I think as these alternatives, you know, really develop, I think we should really, because the glass is there, I think we just have to make sure it stays in the system.
Yeah, I think I would only add, you know, I think somebody put up the slide of the definition of PGA and how it varies throughout New England. I think aligning the PGA distinction between the states would also be helpful.
I think from our perspective, you know, we're a younger company. We've only been around for about 2 years and 9 months. So we've kind of been developing this within the current legislation that exists. So I mean, for us, I don't know of any legislation off the top of my head that I think would be valuable to change.
Fair enough. Yeah. At this point, I'd love to invite Josh and Eric to come back up to the virtual stage. I know you're chiming in the chat, but feel free to turn your video on. And I do have some high-level questions for the whole group. You guys can still throw stuff into the chat box. And I guess if I missed anything, let me know. I guess maybe type it in again. I'm trying to scroll through. I think I got them all, but let me know. But yeah, so thank you so much for all of you for bringing your expertise here today. I hope I hope everybody feels like we've gotten a diversity of perspectives. I wanted to just kind of, now that we've got everybody back here, some higher level questions. I guess one, and we're going to have that problem where nobody's going to know who should talk first, but we'll address that. Do you foresee, you know, given all that we talked about today, do you foresee a future where demand for recycled glass, you know, is like metal and plastic and other things where it's really, you know, you've got a sucking sound rather than, you know, trying to push it out into the world? You know, does it, you know, cease to be that net negative on the MRF balance sheet? And actually, you know, we start elbowing for supply? And why don't we start with Pat?
Sure. Well, and again, I think we all have the same issues, right? We have, it's a sausage factory, right? There's feedstock economics and there's end product economics and there's the cost in between of real estate, plant and capital and operations. And so depending on how that evolves to get more efficient and as end market pricings evolve, that's really what's driving, you know, whether Laura and I are, you know, paying someone or getting a tip fee, depending on, you know, our end market for this product. So as those mature and as we all develop more efficient operations, you know, I think we'll move in that direction. But regardless, it doesn't even have to be a positive number, right? It has to be a lot better than landfill, right? At 70, 80, 90, $100 a ton, pick a number depending on your state and region. So to the extent we could continue to improve on that, it's a significant benefit. So, you know, I don't necessarily think about it in terms of positive, negative numbers as I am a benchmark of the alternative right now, which has been landfill. And I think the more we can move along that continuum, the better for all of us, and the better story for the glass industry, the Glass Packaging Institute to be telling the world.
How about, do you want to hand it off to the next person, Pat, who looks like they really
Well, I
want
mean,
to chime in?
Laura's probably the biggest glass producer of everybody here. So, you know, I'm kind of speaking here like I know what I'm talking about, but Laura's got the biggest share of anybody here.
Pat, you're very knowledgeable. We're on a lot of calls together. I mean, I guess just kind of going back to the question from a supply perspective or a demand perspective, from our side, there are a lot of MRFs who process glass very well, who sort it very well. It is profitable. From our perspective, again, it's very regionally focused. It really depends on your end market. And that's why, again, when we talk about the balance of finding outlets for glass, but just an example in the Southeast, we can't get enough glass into our facilities in Georgia and Florida to meet that demand. So we bring glass in from further distances away. So when we talk carbon footprint, if we had better partnerships and sorting practices with some of those MRFs or direct from consumer or whatever it might be, that's going to reduce the carbon footprint as well and help with that demand. I mean, I think if we've got a problem where we're all competing for glass supply, that is the best case scenario. Today, according to the EPA, which is a few years old at this point, it's probably almost 5 years old at this point. I mean, only about a third of the glass that's generated in the US is recovered. So we've got a lot of opportunity. So if we're able to actually recover 11 million tons that the US generates every year, and as we shift away from single-use plastics, it can be more than 11 million tons a year. That is a really great story and a great problem to have. So we welcome that. Let's do that. And that's all the more reason why we need a lot of applications for glass.
Great. Josh, do you have any, I'm just randomly calling on people, like substitute teacher.
I don't know if I can comment on reversing or making the sucking sound a positive sucking sound. I mean, maybe talk to MRF operators and talk about glass, and many of them grumble. And I don't think that's me. I think that's pretty well known. I think I want to just get back to the trade-offs, because Laura mentioned a lot of really good things. But like if a bottling plant is cost $60 million to build, and the place where the demand is in Georgia, and to build one up here doesn't make sense. You have to widen your vision to factor that into the reality of what we're talking about here. It is most efficient to have all of those beverages go through that one plant and then go out to their distributed places. But to then get the glass back is extremely difficult at an economically viable way. But I totally agree with Laura. I'm just pointing that out as one of the challenges. But I like her framing. These are good problems to have. I also like the comment that having multiple options, a diverse array of options, is beneficial to all. And I agree. And we see that with many waste materials. The more materials you try and capture, the more issues you run into. But the more downstream options you have, and potentially if you can lift up higher and better uses and keep supporting those, then you can possibly increase the value overall to the whole equation. So I don't think glass is going away. Because the other thing we're not talking about much is just consumer demand, which I sort of hinted at the beginning. There is consumer demand, and what we're not talking about is what a brand decides to do with their product. And that connects to Rob, it connects to Jacob, Laura, Patrick, it connects to the MRFs and the people in the middle that are the waste managers of everybody's stuff. So yeah, and that study I highlighted is just one study. It's sort of comparing and contrasting. This is, is just one Can Manufacturers Institute lens on the world. But I'm really impressed by everybody here and what they're trying to do to recover glass. And I think what their actions here today are going to probably reduce the sucking sound or improve the positive trends for glass, no matter what. So that's a positive for me.
Yeah, I think it's going to be interesting too on a macro global level, more forward-thinking countries in Europe that are looking at plastic and food and containers, how food and beverages are sold, and the importance of glass and minimizing plastic, to see where those trends might start in Europe and where they might start going globally around health concerns and issues of plastic and leaching and other things, and the benefits of glass. So that could be another driver of manufacturers as they look at their life cycle cost analysis or life cycle analysis of end of life of their product. The benefits of their product residing in glass versus plastic for their consumers.
I just want to piggyback one comment from Josh and Rob, because it was something that I was going to add too, is consumer buying power. The major reason why Ardagh closed their facility, which this is public knowledge, so I'm not speaking out of turn, was a demand issue. Consumers started to move away from these gorgeous amber bottles behind my head for beer. And so you as a consumer, if you're being more selective in sustainable packaging, or you are not feeling so great about plastics, glass and your buying habits at the grocery store actually matter. So that's just one piece of the puzzle, but obviously a huge part of decision making, specifically in New England.
That's a great point.
I just want to build off what Laura was saying. I think that most definitely it will swing the other way. I think eventually we will be competing for glass. I mean, there's a lot of innovative ideas here, and I think there's a lot more to come, at least from what we've seen, working with universities, as well as just other people our age. Sustainable materials and material management is definitely that's sexy right now. That's something that is becoming, more and more a focus. So I think that overall, just as a society, that's something that's going to start to swing the other way, which will carry this with it.
Oh man, I kind of just want to end on that soundbite, guys.
Yeah, could I jump in?
Beautifully said. Oh, Al wants to say something about what's sexy.
Yeah, since we heard from the young, we'll hear from the old now. One of the things, and I've heard it in almost all the panelists now in these questions, that is coming into play is transportation costs. And we talk about taking cars off the street and the carbon impact, but we have to remember, without regional facilities that are proximate, we're going to add trucks to the street to move this, whatever we're building, whether it's gravel, whether it's Pantheon, whatever it is, we're going to be adding costs to move it. We're going to be adding costs to get the materials to the plants. So regional alternatives, although maybe not as attractive, are really going to, when you start paying more to get your product to a site than the site is paying for the product, the offset is almost impossible to overcome from a sustainability standpoint, a business sustainability standpoint. So we need proximate solutions in New England to create plants. And it's not a shot at Laura, because she offered, but to hear Connecticut, to hear Essex, Vermont, and to hear Binghamton, New York, these are more regional, but they're more reachable, and they're going to help with that greenhouse gas. And there's no drivers out there. There's a lack of equipment, and it's not going away, not in the near term. So something to think about for anyone who's developing a facility or a marketing strategy to consider. Thanks.
It's a great point, Al. Yeah, so that buying power responsibility is on all of us. We do need to find a way to support that regional infrastructure at all the different scales. I'm looking at the time. We're in our closing minutes, and I'm hoping Al has a couple, whatever SWANA chapter wants us to say at the end. Give me a nod. You got something to say at the end
just
here?
Spoke for like a minute and a half.
Aren't you supposed to encourage people to join? I have one more thing I wanted to say, but okay, think about what you're going to say, Al. I'm going to turn it over to you. I think, to moderate this appropriately, I want to have some sort of closing thought or synthesis. And I think if I had one, it would be, that the theme to me was that there was this old mentality, which was basically the only way to recycle bottles or recycle glass is to put it into bottles. And I think, it's still clear the great benefits of recycling glass into bottles. But I think this idea, the flip side of it, that everything else is just like fake recycling or just, it's not real, is really coming into question, as you listen to what Pat and Rob and Jacob and even Laura, the non-bottle recycling options that are out there for glass, they have legitimate environmental benefits. They have significant climate benefits. And so this dismissiveness towards non-bottle to bottle recycling outlets, I think we all have a responsibility to challenge that, because there really are, there's a solution for every problem. And I think there's no one stream of glass. There's a lot of different kinds of glass, and similarly a lot of different solutions. And I think we all need to push for those to be embraced on equal footing rather than having sort of picking winners and losers based on imperfect information. So again, that's my takeaway. I'm sure others have some thoughts. We'd welcome any feedback from the attendees today. Thank you again to our panelists. You guys were fantastic. I learned a ton. I have a lot of notes, and I'm looking forward to continuing to learn from you as you all get up and running in the region. And with that, as promised, I'm going to turn it over to Al Sabino for some very carefully pre-prepared comments.
So I also wanted to say thank you to the panelists. I mean, you made for a great presentation, and our attendance was good. We were in the 45 range, which is pretty good for these webinars and things these days. So we appreciate all the people who attended as well. If you're not a SWANA member, we'd love you to join the Northern New England chapter. It's fairly cost efficient. It's a personal membership. It's not a company membership. So, and as you can see, just from the panelists that we have, you've been exposed to all this great knowledge from young creative people to people who have been in the industry for 45 or 50 years. And we're all sharing amongst ourselves. And that's what takes for these difficult solutions, not just for glass, but for other things. SWANA is Solid Waste Association of North America. That's really a piece of us. New England's always been ahead of the curve on developmental things. And I think we need to continue to do that in order to, solve some of these issues. And the only way we're going to do that is together. So I also want to thank Abby and Bob Spencer and Denise Mungin of Eco Maine, who, without Denise, she puts all this stuff together. And Abby did a great job moderating. So thanks to them. They made for a great presentation as well. These are, believe it or not, these are not that easy to pull off. And I think this one went really well. So thanks for everyone for attending. And I think the next SWANA one will be the main presentation. It'll probably be up in Portland, but hopefully by then, maybe we'll be able to start getting together and, either bump hands or something anyways, that we can actually see and interact with one another. So thanks for everyone's time. Appreciate you attending.
Just quick random, Al, you said Maine a couple of times there. We're taking Glavel on the road, and we're actually going to be in Portland, Maine tomorrow evening. So if you want to see Glavel in action and you're in the Portland area, look at our website. The information to sign up for the demo day is on our website. We'd love to show you the product, get you some beer and some pizza as well.
There you go. Road trip, guys.
Yeah. Now Glavel is going on the road or is the road? We just
we're going on the road.
Okay.
Yeah.
All right. Sounds good.
Thanks, everybody.
Yeah.
Have a
Thanks,
great
everyone.
one. Bye.
See ya.
Be well.
Thank you.